Kiwi, thanks for joining us as the official diploma juror. Second thing is, you can see now, if everybody could mute until we're ready to have a conversation, that'll go well. Also, everybody that's not presenting or on the jury, if you would turn off your video, that'll also help things a little bit. As Sabina said, we're going to record this unless anybody has any objections. Okay. You know, if you need to send messages or anything, I think everybody knows there's the chat window, so we can do that. I would also point out that private messages aren't private on this. So anybody that grabs the record of the chat sees everything we say, so be aware of that. So we're going to start off today with Hani's diploma students. So Hani, if you want to give a little introduction to everybody.
Hani, you're muted.
Okay, good. You hear me? Can you hear me?
Perfect. Yep. Okay.
Good. All right, well, good morning. Good morning from New York, where I happen to be. And it's kind of a surreal event for all of us, I guess. We went through our own reviews the last couple of days. It was actually, they were quite successful given the circumstances. And today, I guess we're looking at the thesis. This morning, we're doing my students first, I believe. And I really don't have a lot to say other than the fact that I admire their perseverance and their commitment and their passion and the ability to actually, for all the students, I'm sure, across the whole school, to have worked under these circumstances, which have been pretty interesting and pretty trying. It's also been interesting to watch the students struggle with and accomplish a great deal without necessarily the use of tools and machines that they're all used to. So I think we're seeing kind of a very, very powerful graphic sort of push here, the things that you can actually do in isolation, as was the case. So I think we're starting with Alexandra Ahmed. Are we starting with you? Is that right? Okay, good. Alex is first, and yeah, let's get going. I'm going to try and stick to 30 minutes each, I believe, right? And I'm going to get some kind of an emoji from Eldine all the way. Okay. All right, let's get going. All right. So first, I guess you'll share your screen and go through your presentation, right?
Yes, I just need to be able to share the screen. So whoever is host, please enable it, and then I can. Okay. Hi and welcome to the 2020 Architecture Thesis presentations. My name is Alex, and today I'm going to talk to you about my project, The Temple of Food. In this lecture, The Biology of the City in 2011, Manuel de Landa said there have never been cities that could feed themselves. They have always been parasitic to the countryside, which led me to the investigation to investigate the connection between cities, the flow of goods, and its relation to architecture. By 2050, we will need to increase the food production by 70%, which means that according to the FAO, the Food and Agriculture Organization of the United Nations, we will need to produce more food than in the previous 10,000 years combined. Additionally, our agricultural industry uses 70% of our freshwater resources, making it the largest freshwater consumer in the world. Historically, food production used to be a vital part of the village organization. Farms were in close proximity to the end consumer, thus reducing the transportation to a minimum. Therefore, the awareness of how food is produced was very high. Today, the process of food production is split. With multiple steps of transportation between processes, we lose 30% of the food that we produce. In my conclusion, the future of agriculture has to be urban. By moving agriculture to our cities, we can bring the awareness back to the citizens and at the same time give nature back the space to restore and heal. Vertical farming has become an increasingly affordable technology. By using 99% less land, fertilizer, and no pesticides, it also provides a sustainable solution for our future. The proposed system works on the basis of a closed nutrient cycle. By combining aquaculture with hydroponics, we can create a solution independent to external nutritional inputs. In order to create a future that is resilient, we need to build this ecosystem that is regenerative by design. A symbiotic cycle between animals, plants creates self-sufficient food production, and by introducing a robotic farming system that can adapt to local needs, we can also limit the food waste to a minimum. Furthermore, the Temple of Food can become a place to meet and share knowledge about food. The proposed project is positioned in the 19th district of Vienna. Close to the Danube Canal, the area also known as Mutgassenviertel is already undergoing new urban planning thoughts since 2014. The building site, Mutgasse 1, is currently occupied by the APA Tower, which was built in the 70s and used to be the office tower for the Austrian Press Agency. Since 2005, it sits empty and will be taken apart by the end of this year. The plot is also chosen for its proximity to the University of Natural Resources, which is in short the BUKU, as a possible partner with the Food Technology Department, and also to the proximity of the Karl-Marx-Hof as a symbol for democracy and the social architecture of Vienna. The initial formal investigations led me to develop a series of topological experiments by using the game of life algorithm developed by John Conway in the 1970s. By creating a set of rules for its growth, alive and dead cells form a three-dimensional porous tower structure, with each cell being aware of its neighbors. Continuing with this set of over 100 selected topologies, they were then evaluated by radiation on the site in order to differentiate between spaces that are better suited for plants and spaces that are better suited for people. From the volumes that have a higher radiation level, the farming volumes are created, and with the final tower being able to produce up to 400,000 crops per week. The cooler spaces are then separated into the aquaculture and technical spaces, the lab spaces for the close by university, public spaces such as farm-to-table restaurants, and dedicated spaces for public farming. Additionally, on the rooftop, it is housing a sky park with pools and a rooftop restaurant. Divided into the individual components, we can see the different levels on which the Temple of Food can be explored. By creating different paced circulations, the tower can be explored in two different modes. Either one takes the spiraling educational walk that leads you through the humming sounds of the moving robots and the fresh smell of vegetables to the mid-level cafe on the east side of the tower, or you can take the elevators in the central core directly to the top to enjoy the view. For the auditorium and lab spaces, the core houses an additional elevator that also connects to the aquaculture and technical facilities in the basement. The main structure of the tower is based on the 3x3 grid that the initial topology offered me, and the circulatory ramps and the functional floors are then spanned between the 15x9 meter core and the farming structures. The profiles of the farm are then size optimized in order to create an optimal performance under the load of the farm. The farm structure also creates extra support for the cantilevering elements of the structure. And then by using evolutionary algorithms and optimal position, the optimal position in between the robot circulation is found for the market foundations. And then a BESO method, so-called finite element-based topology optimization, is used to explore the design space in order to find a structure that can hold up the market gardens and its roof. The plants grow in so-called farming voxels within the tower. When ripe, they are picked by the smaller farming robots and brought over the horizontal conveyor belt structure that moves them into the central core. There, a vertical food elevator can transport the crops to the restaurant or the market, and then the fresh crops can be used for the farm-to-table restaurants or can be hand-picked on the market level. The site plan shows the proximity also to the Danube Canal, which is a vital part for the city for leisure and regeneration, but also on the left side of the building, there's the possible connection to further plans of a green highline that the city is currently working on. In the section, you can show the section shows the cantilevering ramps that are connected to the core, and the facade of the tower is a Mullion transom design that is held by the farm structure. The loads are then transferred into the micropiles that go deep into the ground to ensure that the tower doesn't move with the high wind loads. The market structure consists of a space frame with circular aluminum profiles and automated glazing structure for air circulation. The market flow shows the different archipelagos and the ponds that can be explored once entering the market from the north, by either walking up through the educational walks in the tower or through the circulation within the market. The garden, you can get to the garden level on 14 meters height. And the east entrance to the tower is mainly used by the researchers and staff members. The auditorium and lab spaces additionally have a kinetic shading element for it to be possible to create an optimal workspace environment. And the extra circulation in the north of the core is only accessible for researchers and auditorium visitors. The public farm levels show parts of the educational walk, but also the cantilevering elements into the farm that act as window to the city. The elevations show that the public functions are woven within the lush green areas of the farm while keeping the areas that need shadow in shade. And finally, I would like to conclude the thesis with this short movie that wraps up my thoughts on the future of agriculture and its meaning for the city. And you have to turn on the sound because it's narrated.
We lose 30% of the food we produce. On top of this, farms are moving further and further away from the end consumer, becoming remote and independent entities. Cities have proven to be non-self-sufficient, incapable of producing enough to feed themselves, relying on large expanses of the countryside as an integral aspect to the food supply chain. Along with this, the transportation of food from the farms can create a lack of product quality whilst largely contributing to the global carbon footprint. With the increasing rate of urbanization and densification in our cities, the current agricultural methods need to be rethought. The proposed vertical food production hub can change the parasitic behavior our cities currently have with the countryside, becoming central hubs for knowledge sharing and social gatherings where the growth, production, and consumption of food is reintroduced into the local culture. Therefore, instigating a communal and individual food awareness that will sustain urban farms and a healthier society. By bringing the people closer to nature, a more eco-centric society becomes possible. This creates a space for a new typology that praises humanism and worships nature.
Great. Thanks, Alex.
Thank you, Hani.
Lots of virtual applause. All right. So I guess we'll open the floor for discussion.
I had just a question before we start the discussion, which is, Alex, can you talk a little bit about how you move all the raw materials and products around?
Yeah, of course. So the idea is that when I just quickly jump back to the, I didn't talk about this diagram, I just see. Well, the idea is that, you mean how the fresh products come from the tower to the farm?
Yeah, that just, in general, how you move the raw materials and then the finished produce around, as well as how the people move around.
Yeah, so for the people, the idea is that I have these two modes of circulation. So one would be this kind of spiraling ramps that move up the tower, where you can actually go to mid-level, and then from mid-level you would have to take the elevator, so not all of the levels are accessible all the time. But then the robots actually bring the finished crops. Do you see the video by chance? Mm-hmm. Yeah. Bring the crops from these elements over to this kind of, so when I pause here, what you can't see in this video is the core. So I'm hiding the core. This sits at the core basically. So I have these three times I have these conveyor belt structures where the finished crops basically move into the core, and from the core it gets either down to the market or up to the restaurant, depending on where it needs to go. And obviously the robots have these different sizes in the market. So in the actual farming voxel, it's quite a small robot in order to don't damage the crops and so on. But then the ones that move the whole trays, the crop trays, they can be larger. Yeah. That was the idea.
But can the public, I think Greg was also asking about the public circulation. So can the public witness all of that somehow?
Yes, definitely. So while you are moving through the building, you are actually in the farm in a way. So I think in the video in the end, you can see that basically all these robotic movements and so are happening within the building. So while you're walking on this educational walk, which I thought can also enhance in a way this awareness about what kind of plants are grown there, you can actually see the process happening. And basically, the tower is basically where stuff grows, is the farm, and in the market, only the finished products are put.
But what would take people up into the tower? Just the desire to walk around in the farm? Or is there something?
On one hand, since we're talking about this scenario of 2050, I was thinking a lot about automation, and a lot of jobs are going to be lost. So that's why I put this idea of the public farming in there. So on one hand, you can go there to either go to the auditorium, to the lab spaces if you're a student. You can go to the 3 different restaurants you have, or you can go there to actually farm. So even if you don't have a job anymore and there is this universal basic income possibility, you would have the possibility to do something in the farm, in the tower structure. And of course, on the top, you have the pools and the sky restaurant, which could act as an attractor as well.
Another question, how do you bring sunlight to the plants that grow more in the interior of the tower?
Well, the whole, all of the farming voxels actually have LED strips. So in the end, like the last image shows basically the tower lit up once you don't have the excessive sunlight. But discussing this a lot while talking about the energy design, it made more sense to have actually, well, basically the voxels are put where sun goes, right? So this already kind of optimizes, let's say, kind of the position of the plants. But then eventually you also need the LED strips to also enforce, in a way, the fast production, because with this vertical farming solution, as I said, we can produce up to 400,000 crops a week, and this can obviously not only happen without the LED stripes.
Mm-hmm. And where do you take the energy from for that?
Well, on one hand, it is obviously should be used solar energy, because it would be a pity if this is all generated by coal, for example, or something. And then on the other hand, I think with producing this much vegetables, it could also be interesting to think about, bioenergy maybe, or something like that, because the tower could produce excess material that could be then used as biodegradable energy source, for example.
Say something? Yeah, hi, Alexander, that's you, right? Yeah, I particularly appreciated the reference to cellular automata and the way they show up in the final design. They're used soberly, advisedly, and I think they look good. If I had to use cellular automata, I would probably not have referred to the Game of Life, but to Stephen Wolfram. I'm certain you're familiar with his work, and because it gives a more up-to-date, truly mathematical interpretation of how cellular automata are a new kind of science. I think you have a very good argument on that. And you might have used his argument, meaning in your game, because it's a new kind of everything that you're showing. Concerning the automation of the internal distribution and all the conveyor belts and elevators for potatoes going up and down, I understand that since you had to insert this into a building of the 70s, this kind of makes sense because it is related to the spirit of the place, so to speak. Generally speaking, if I think of the future of farming, I would prefer to think of robots that can keep farms as farms and deal with potatoes as potatoes, instead of using mechanical automation to convert a farm into a factory. which is a tendency which is frequent today. You bring mechanical technologies to the countryside and every farm becomes a factory, but a factory of 50 years ago, not a factory of today. Whereas today we have technology to make factories that look more organic. So why should we not use these robotic intelligent tools to deal with potatoes as potatoes and with tomatoes as tomatoes? But I can see that in your case, using elevators was in fact a very good idea because it's a tower. So it's better to have elevators going up and down than robots climbing stairs. So but in your case, that makes perfect sense. So good, congratulations.
Thank you.
Yeah, I think that it's interesting how if you think about architects like Corbusier being inspired by agricultural buildings and thinking what it is to bring a language of silos and storage and distribution into the world of civic buildings. Here it really feels, and I think it's appropriate, but I don't know if you agree, Alexander, that the language is really the language of a server farm rather than a real farm. It really feels to me like a machine that is not meant to be primarily experienced by people. So that's why I'm kind of curious about how far people go into the building and what the civic presence of it is. I think that image you had before of the kind of twilight view where you see it glowing, it especially looks like you've brought a server farm from the middle of the desert somewhere or the countryside into the city. Only instead of data, this is dealing with organic material. So I think the language is very interesting. I think the kind of racks and space frames, that when you build a server farm, you don't really even think about, you're not thinking about human occupation. You're thinking about racking machines, and those machines need to be accessible, but they don't really obey any logic of civic space. Yeah. So I don't know. I think the kind of the foot of your project where you have the hall is very civic. I think the tower should probably, just be a machine. I mean, I'm not sure. The spectacle of it might be interesting, but I don't think you need to bring human occupation through the whole thing. And I'm interested in what it would be to design for a plant rather than a human. So I don't even know why you need floors up there, to be totally honest.
The thing is that when I started this whole project, actually I was struggling with the scale a lot because I started to try to design for plants actually. And then once you look at a salad crop that has maybe 20 centimeters, suddenly everything starts to have a very weird scale, right? So Hani still remembers my early adoptions of the project where we weren't sure if this is super large or if it's super small, right? So I think this, what you said with the racks and the server farm is very true. And I think it comes from me trying to merge this whole idea of data with kind of the problems that we face with the food kind of environment that we're in, right? So in a way, I think it was my turn on trying to rationalize kind of this machinic thing, but also make it somehow make it a spectacle in a way that you want to climb this tower, right? Because that's why also in the video Jade was saying that it is a hub and it is one part, and definitely what you're saying is true that it doesn't need those floors, but I see it more as one project, and then the rest of the city has maybe more of those hubs without the floors. So this could be this one element that has the floors and has this spectacle and has this attraction, and let's say there are 5 more which already could feed half of Vienna, and these would be kind of more of those silo types.
On the energy side, I think we've been doing a lot of research into vertical farming and energy, and so I think this is the first diploma project at the Angewandte with a vertical farm in this scale, I think. So congratulations.
Thank you.
The energy, what the research actually shows in the end is that in terms of energy, even when we work with daylight in this sense, the amount of energy required to drive this farm to make it really work the whole year round in a climate like Vienna means that at the end of the day, you need a huge solar farm at the foot of the building, which is basically supplying the building with electricity. So actually the research shows that to measure whether it's effective or not, you measure the size of the solar farm and you compare it with the size of agricultural, traditional farming land that you've saved. And that's the way we actually measure the efficiency in terms of land use, not in terms of kilowatt hours or whatever.
Yeah.
So you have to be aware, of course, that either you take electricity from the grid, which which depends on what the grid is doing. But to make this really work in an effective way, you would need a lot of solar horizontal at the base of the building to make this work autonomously, or to that's the future of vertical farming. It's definitely a huge amount of artificial lighting energy required to make this work. So, but congratulations, there's a lot of interest in this topic for a long time, and I think it's getting to the point where we can make serious projects. So I think there's a future.
Thank you, Cody.
And what Greg said is, of course, true. And this is something that a lot of the projects do. You tend to think always in floors. And actually, when you think of plants, they have different dimensions and it comes. But I think it's important. I think the potential is also in mixing the typologies together. So because then, for example, CO2 produced by plants can be transferred to human occupants and other areas stuff. So bringing different mixed use typologies together has potential too. So, yeah.
Alexander, could you please go back to this section and tell us a little bit about the structure and the principles? What we see here is cantilevering slabs and partly suspended slabs. What is the principle?
Yes. So the idea is that mainly we have the core in the center, and then we have the cantilevering slabs and the ramps. But I think in the section it looks a little bit like they are flying. But actually, if we go back to the Caramba analysis, to this one, actually they are supported by the farm itself. So it's basically the system works basically that you have the core in the center, then you have the slabs, and you have the farm supporting it. So basically all of the floor slabs. Except two places where it's cantilevering a bit more, where we also have kind of this effect that the floor slabs are getting thinner and we have lighter. Unfortunately, I cannot zoom in here, right? No. And we have this effect that the beams are getting thinner at the end, and everything is supported by the core and the farm. So that's the idea of the structural system. And then, of course, the farm itself is beam optimized, so we don't use too much material.
Okay, the farm means this rack system, the steel structure.
Yes, the metal structure, yes.
Okay, so they are not that thin as we see it here, but it's quite good. Yes. Thank you.
Thank you.
I've been given the 5-minute warning.
Okay, all right, let me say before the time runs out. I think it's a really compelling and beautifully and professionally presented project. And I think it's always a good sign of a good project that it projects forward. I think Greg is the one who always points out that your thesis project should somehow launch your career into the future. I think in those terms, you've done a great job. There's a number of things that I scribbled down here as you presented, and one of them was that it seems that the entire design process is set up as a problem-solving exercise, that you explain what the problem is and then you solve the problem. And going forward, or maybe if we have a little bit of time, it would be interesting to listen to you talk about what you might have discovered that was unexpected, what the project generated, because of the manner of the logic of the presentation is very much solving a self-identified or created problem. So that's one question. And then I wonder also, it's all very compelling, and which makes you wonder about the enemies of these projects. And I would have asked Klaus actually what he thinks about the amount of water that has to be pumped up, and the amount of soil and the weight and what that does to the structure, and that coupled with the sizes of the plants, you would expect that actually, if this was to realize, it would result in some kind of radical architectural design, just because the criteria is so different. But it also might kill the project, because it might be unfeasible to put that much weight up or put that much water up, and so on. And then maybe the last point has to do with, that's an aspect that I perhaps missed, or you could have explored further, which has to do with circular economy and this whole idea of urban metabolism, that there's a beautiful description of how the plants are grown, and then they're fed into these different systems. But you did mention it, but the whole project could have been described even more in terms of circular economy, how there's no waste, how the wasted plants are eaten by crickets, which are then served at progressive restaurants, and so on. So it could have been presented a little bit more in terms of an ecosystem. But I know enough about these farming systems by companies like Green Automation that everything you say is feasible, and this is how it really works. It just rarely works in tall structures at the moment. What you do, you create very, very large expanses, horizontal structures over existing buildings like Whole Foods and so on. But all in all, a really exciting project.
Thank you.
Okay, are there any other last comments, or?
We would like to comment on something. And I think following Greg's comments maybe about, the radicality of the proposal, I have doubts about how productivity and optimization is crucial in here versus, certain inherited typological formations. In a way, if I'm understanding the project as a productivity machine that is trying to find a way of optimizing the production of food within the city and making it public, I would expect a more radical, both climatic, structural, and also heliotropic organization for the tower. So that is changing the typology of a skin and core of the corporate office buildings, the vertical buildings. In a way, the centrality of the core, the centrality of the core in relationship with the structure and the rigidity of it, and the relationship also with the. Sorry, I had to drink something.
Okay, I think we'll stop there. Any more? Okay. Like herding cats. Okay, go ahead.
But I would expect a more clear and radical organization. Also politically, for example, I understood it as a continuous space, and where the gain of solar radiation will make the temperature vary drastically from the bottom to the top. Yes. So we would expect that something that is related with the different growth and different size of the tower as well. So that is somehow a negotiating the centrality of the core with other more radical movements, as with the structure as well. If the steel structure is playing a role on it, I would expect the thicknesses to be growing and maybe organizing the crops vertically differently, and not in this both homogeneous and random way. So I think there are like super interesting things in here, but I think the given initial organization of the tube within tube, typical from corporate vertical offices, I guess that kills a bit of the possible radicality of the proposition.
Something super short. I know that we are running out of time. Alex, I really like your thesis. When you explained that you want to propose agricultural and how agriculture could be urban, I thought this is brilliant. And maybe following a friend's point, you could have thought, or maybe in a longer time, maybe a semester is short, you could have thought about the translation of agriculture in a urban context that is vertical, of course, because vertical makes sense, but not maybe a typical tower.
Yeah.
I think that this is the
So I just want to let's end there, but I just want to say also that I also was perplexed throughout the semester, actually, with Alex on the let's say the formal move here, right? The fact that it looks a little bit like an office building or a hotel or something. But then, you know, going through this pandemic and watching situations, especially here in New York, with you know, people asking now, what are we going to do with these office buildings? When people don't want to go to work in them anymore, when people don't want to take elevators, when they don't want to social distancing and all of that that's taking place here, at least 2 or 3 people I know who own quite large spaces here are worried they're not going to put their people back in their offices. So I started reading this project, post-reading it now as you were presenting it, as what happened here, for example, with the AT&T tower, which was gutted completely, and then they didn't know what to do with it. They have this giant empty, you know, 40-story building on the East River here, on the Hudson, that they don't know what to do with. And I started thinking, you know, and I know it's not what you intended to do, but just in terms of those questions, which I agree with you guys completely. It'd be interesting to think of this in terms of what Brian had said as a way to refurbish existing buildings and basically gut them and turn them into farms. So it's just a side note, and it's a post-COVID-19 era side note, but I just thought I would throw that in there. Let's move on. Thank you so much.
Thank you,
Alex, and thank you, everybody. And
congratulations, Alexander.
Congratulations. Thank you, nice project.
Julia's also watching from here. So.
There's some kind of a peanut gallery screaming in the background.
Yeah, we have public viewing.
Like a sports event.
So hello everyone, my name is Leonie. I will present you my thesis project, A Hybrid for Enhancement, which can be seen as a human performance facility in order to optimize the mental and physical capabilities of the human form. So through the simulation of extreme thermoclimatic conditions, and the celebration of science and human supporting technology. So the project could render a starting point for special forces and interdisciplinary teams from sectors like health, military, and space travel.
Leonie, are you sharing the screen?
Yes.
No.
Oh, no. I'm sorry. Wait. I thought it's automatically shared. I'm sorry. Can you see something now?
Yes.
Okay, perfect. So now I hope it's okay that I repeat the starting point. I forgot to share. So now can everyone see my title image?
Yes.
I will So as you heard already, my project is a enhancing performance center in order to optimize the physical and mental capabilities of the human forms. So it can be a starting point for special forces, interdisciplinary teams in the sectors like health, military, and space travel. So as you all know, the increase of climatic changes, natural catastrophes on our planet, as well as additional consequences such as epidemics, pandemics, as one of humanity's greatest challenges will also affect the state of health and well-being of the humans, which means we need a change, and it requires a kind of adaptation and resistance in immunity. So the transition from sick care to healthcare basically is describing the process and the development of self-optimization, prevention in healthcare, the constant monitoring and health tracking. So in the connection of our changing environment, we are finding ourselves in the enhancement revolution with its three main forms. The mental, which is described through cognitive optimization, the physical in the way of plastic surgeries, doping or enhancing drugs, and the artificial is described through exoskeletons, prosthetics. So my project is a combination of three main modules, which are expressed in a spherical appearance, contributing as a spatial hybrid to the human enhancement. The simulation of microclimates, which aims to optimization of the adaptation in simulated internal extreme artificial climatic conditions. And the cell factory, the other one, a kind of stage for science and research, is celebrating a kind of new interpretation of the historical anatomical theater and offers a space for research in medical, pharmaceutical, but also in biotechnological approaches. And the last one, the testing ground, is researching and testing human supporting technologies like prosthetics and exoskeletons. The test will be like testing on radiation, water, and pressure. So based on the long health culture in Japan and the state of new center of medical technology, I will place my project like 2 hours drive from Tokyo city center Shibuya next to the Fuji mountain. So the site is surrounded by leading companies like Fanuc, which is a leading company in robotics, and other military camps and smart city projects from Toyota. So the spatial arrangement and the program is divided by dynamic and static sequences and a singular and plural use of the spaces. So the composition is arranged next to an existing private health university, which I include in the layout. Through a continuity of the circulation, I create a connectivity between the three main modules and integrate the university and create public squares and places at the intersection point of the circulation. So the connectivity is also a base for the cuts through my volumes, for the circulation and the natural light income, and also for the design of the facade elements. So in the following, I will focus on two main modules, which are the extreme simulation of the microclimates and the cell factory. So as a starting point for the simulation of the extreme climatic internal conditions, I start with four main conditions: hot, cold, high humidity, and less oxygen. So the vertical arrangement of the four main categories of the climate condition and the use of concrete panels at the facade, which will include solar fluid, gives the possibility to use solar heat as a main supplier and use the return flow of the heaters for cooling. So this basically means that at the beginning of the process, the fluid heats up through the sun, is compressed in the compressor and becomes then even hotter. Afterward, it expands, gets cold and becomes over the process warm again and will be modified to cool again the polar capsules, for example. The beginning of the process starts basically in the facade and ends up then in the capsules. So a central pool for the non-gravity practice is surrounded by the microclimate capsules, which are oriented through the to the pool and will be accessible from the back side. So a main ramp for my main circulation in this module is basically surrounding the central pool and is creating a connectivity in the fuse and circulation. So as a next step, we are entering the second module, the so-called cell factory, which is offering a kind of central element and the new interpretation of this historical anatomical theater, and celebrates the kinematic of technology. So it can be seen as a stage for science and opening up a new interaction between the human, enhancing technology, and the human. A main underground connection is helping a self-contained circulation for the central end space. So the shell will consist out of prefabricated concrete elements with an oscillating shell as a foundation and connected with earthquake-absorbing dampers in a form of coupled tension members and damping springs, which is a kind of answer to the seismic danger in Japan. So the central theater-like space is surrounded by a ramp which allows a view from multiple levels. A central element can be seen as a connection point of a non-human, the machine space, and the human space. And on the side, I will place the training capsules, which you can see in the back of the image, located and allow kind of individual practice. So a kinematic and rotation policies and practice of remote or image-based surgery will be happen in the little capsules you saw in the image before. Also, a complete enclosure allows to simulate extreme situations. So the central shell allows through its kinematic an airtight and completely closed condition. It offers also to hold workshops and be completely inherent self-contained airwise. But through the glass, the elements are always visible and also for the audience, view-wise always accessible. So the core element has the possibility to rotate around 360 degrees around the Z axis, which gives a perfect view for the person who is giving the workshop. So finally, the project can be seen as an architecture, which is not just a shelter, it's more preparation for the seemingly uninhabitable extreme climatic condition. The project can be seen as a kind of architectural apparatus and spatial facilitator for the human enhancement. Thank you.
Great, thank you. All right, so anyone want to dive into this one? I'm going to pick somebody on the screen. I'm going to throw a dart at my screen and see where it lands.
Well, I can ask one or the other question. I had the impression that's sort of a Frankenstein concept. You're going to change humankind, or are you trying to create a better mankind, or what's the real goal of that strategy?
I mean, the idea of the optimization of humans is already through the self-optimization process a big topic at the moment. And it's not about changing the human in its species, it's more about that the architecture should also play a role in this optimization process.
But you are treating candidates, or did I misunderstand that?
It's more that they get prepared. It's not that they will practice, for example, their exercise. It's like an astronaut, for example. An astronaut is a good example how to prepare actually for extreme climates. So he will do his whole technology exercising, for example, underwater, which means he has a whole team in his back, which is helping him fixing parts, screwing things together, learning how to save or help his teammate. And then on the other side, he has dry exercises where he has to learn to work in social isolation also, for example, or has to learn the communication in kind of emergency situation?
I mean, for me, I think that I don't want to sound like a really old person that's always referencing old precedents, but it reminds me a little bit of anatomical theaters, in the sense that you feel like being the subject in the anatomical theater with these spherical spaces with things coming to manipulate you. And also, I know you didn't begin your project during COVID, but you developed it during COVID. And I can't help but think of a couple of medical appointments I've had online, and a minor surgery I had, where I had absolutely minimal contact with human beings. And so I think the issue of the climate is one thing, but I think the issue of a new experience of medicine, let's say, or health is very interesting. And I think it's a very specific take. It's for me very like $6 million man Steve Austin is kind of what Matthias is asking you. Like, are you making a bionic human? But I'm not sure I mean, I'm curious about how sci-fi it is. Like, it's very sci-fi, both in looking towards the future, I think, but also a little bit nostalgically sci-fi.
I mean, it depends how far I will go. But for example, there is already a project in the UK, it's called Blue Apsis, where they're already actually planning a kind of performance facility. It's more based or like more aimed for private astronauts, let's say, but it's kind of aiming similar topics which are also in my project. So on the one side, it can go really in a sci-fi direction, but on the other side, it's can also start in the next 10 years.
When I was in Hannes treats a couple of days ago, and that was my learning curve, because it was the first time I saw project of the school in a sequence. And then Hanny warned me that there are a few motifs that are part of the DNA of the school which are frequently recurring, including that of the broken sphere. Now I understand that that was not a practical joke. I've seen plenty of that. In this instance, I think it does relate to a kind of vintage science fiction and the idea of the biosphere, which is also part of your program. So you're creating the simulated extreme environments, which some biosphere projects of the 60s and 70s were also trying to do. So in a more transparent or implicit way, your broken spheres also relate to that vintage sci-fi tradition, which is what Greg was suggesting when he said that there is this sci-fi component, but it is also a bit nostalgic. It's nostalgic of the sci-fi of 50 years ago, which is a bizarre feedback loop. And then there is, of course, for people of my generation, the permanent discomfort in dealing with these biological topics, not metaphors, but real programs, because we were trained in architecture in the, at some point in the last century, and our training was mostly in the mechanical sciences. But whenever we have to deal with the sciences of life, in biology or medicine, as a metaphor in design, or as an actual program, as in your case, we don't know what's going on. So we always feel that we are trespassing into someone else's territory, which is why we are a bit delayed in our reactions on that. That does not apply to your generation, like here.
It's interesting, this question of sci-fi, because just one thing is that I was really struck by two things. First of all, Elon Musk, it seems to me, is embodying this problem at such a large scale, right? Everything from his Hyperloop to to the space suits that were just put on these astronauts, which looks like something out of Stanley Kubrick, out of a Kubrick film. So I think it's part of a kind of a weird zeitgeist of this loop back 50 years to the future, which is really interesting and weird. And also the number of people who signed up for the trip to Mars is extraordinary. And I think part of what Liana is banking on, if for lack of a better word, is that there are a lot of people who are willing to sign up for some kind of augmentation, some kind of testing, some kind of pushing the limits. And yes, I think there's something to that. Also, the biosphere is an interesting thing. It was a failed experiment in socialization, and one wonders what happens here, right? In terms of what Greg had said. But go ahead. That's all I want to say. Kiwi, I think you were about to say something.
I think it's. I liked Greg's notion of new experience of medicine as some sort of motive or aim for exploration here, but I agree what others have said, that the project is somehow in a really intriguing way balanced between the future and the past, and nostalgia and science fiction. And your discussion of it focuses mostly on the program, if you will, but then what I'm looking at here on the screen, it's this quite intricate and wild formal exploration that's actually, it's a vocabulary of fantastic little discoveries. And I think just on that level, the project is quite exciting. So you really, what you have here is on one hand a field, then you have clearly these Burle Marx-like figures within the field that constitute the field, which become then three-dimensional objects in a kind of Boole manner, which are then fragmented or sliced open, and then those, the slices become lines, which are seams of the panel. So it goes from surface to volume to field. I mean, there's a lot going on. So as a library of architectural exploration is quite fantastic, and maybe can do with a bit editing if it were to become reality, but I think it's quite successful in those terms. So it seems like this and the previous project and this one both suggest a new typology, and a lot of the discussion focuses on that, the credibility of that typology and how it would work. But one way to look at the project is to think that typology is an alibi for architectural exploration, and then pay attention to some of the architectural discoveries that are made in the process, almost, for a moment forgetting the narrative that got you there. And I think this project is quite exciting in those terms, but it's very hard. There's this one view of the operating theater that made me immediately think of Sweden's oldest university has an anatomical theater, and the view is almost the same. Of course, it's set up differently. Or it makes you think of some sort of death chamber where the chair is in the middle. But
or the plastic surgery chamber in Brazil film.
Yeah.
Yoni, it would be great if you could move your presentation around a little bit to kind of show us some other images.
I'd just like to comment on the energy design. Is very sophisticated thinking to the way the zones are created with the different climates by synergies. So congratulations on that.
Thank you.
Yeah, this is the diagram. So if you look at it, it's very sophisticated in the way it tries to draw out the synergies between the different climatic zones.
Thank you.
We were talking about insulation in the outer skin. What is the solution now?
So at the moment, I will have the prefabricated concrete elements as load-bearing elements. And then I will have a waterproofing layer, then isolation, then a construction which is holding the panels, which are made of this ultra high performance concrete. And in the panels will be the V-like thing, where the solar fluid is going through and heated up and then used for my energy design concept.
Okay, that's a very differentiated and integrated structure.
All right, I think we'll, any other comments?
Yeah. So thank you for the presentation. I have a comment related with something that wasn't commented on, which I think is pretty crucial to the project. You know, I imagine the program that you're dealing with in a kind of obscure, located somewhere shared, you know, where scientists are doing all these kind of tests in a really secluded and isolated place, you know, as many facilities or scientific facilities are doing. Right? So you're doing a couple of movements in here, which I think are pretty important for the project, which is basically making it public. So both literally making it accessible, but also becoming something that comes or that tries to bring people around and that is participating in a way, even if it's only visual or it's just through vision, is crucial to the project. You know, it's organizationally, language-based. Everything is about this. Also, is making explicit. You know, the things that are happening in here, so to speak, not by making it transparent, but by making it formally very, very, very explicit. So I would like you to just, I know that we're like running out of time, but I would like you to talk about this because it wasn't, was somehow commented, but it wasn't that that explicit in your presentation. And also because I think there's a moment in here, if in the post-COVID kind of situation, if this would become a kind of amusement park, or it's a real public thing, you know, where people can be exchanging knowledge. Obviously, you know, the medical theaters of the 18th century were making public basically knowledge. So what it was, bringing people together was like this learning and teaching experience of the body being exposed to others and the techniques of knowing the interior of ourselves being exposed to the knowledge of others. So I think I would like you to talk briefly about it because it wasn't that explicit in your presentation.
I mean, about that, one thing is that they integrate the already existing university. So this can be one step in the direction. And on the other side, that I have the 3 different parts. So interdisciplinarity is also kind of created by that. So I will have different specialized people and they interact and intersect then in working together. On the other side, it depends also on the research, how much it can kind of reach already a public audience. It has also to be proved by some legal and ethical conditions. So it's kind of this 2-path direction. I don't know if this answered the question.
Yeah, I was also interested. Sorry, I don't want to make it very long, but I was interested also in the formal moves because there are like a lot in there. As I was coming, a lot, you know, and you're making super explicit things, you know, with the outer shape, you know, really being somehow gymnastics on form making. And, you know, that there should be a relationship between the two of them, right? Because otherwise, you know, it doesn't matter, you know, everything that is happening inside, right, could be totally interiorized kind of a space. So that you're doing a lot, you know, showing that explicitly in the interior, making explicit the 3 kind of programs, you know.
Yes, on the one side, I mean, the formal approach comes through the circulation and how kind of the 3 spheres are layouted and interconnected and connected to each other. And on the other side, I kind of use the formal language of the kinematic as a kind of ornamentic for the internal spaces and try also concerning views and a continuity open up the spaces and to celebrate this kind of development and kinematic and technology and the merge between the merge of technology and the human. And on the other side, I use it again to open the whole language of the volumes up through the cuts and then transparent layers.
Okay, listen, I just want to, my closing remark here would be that, you know, we as in fact Kiwi had, I think, channeled Greg, who had said, or however the channeling goes about, you know, graduating with a thesis project that launches your careers. You know, I just have to say, having watched you work on this, you're kind of a consummate architect. And but what I mean by that is, it's really great to see someone who obsessively is interested in the sections, in the tectonics, in the mannering of these spheres, in the attempt to, albeit a somewhat strange and somewhat weird program, but get it working into some kind of an architectural proposition. So I just admire your facility, and I admire your commitment to drawing and making form and making things work, which is kind of, you know, we don't seem to be losing that old. In fact, in some ways, you're kind of old school in a very interesting and compelling way. So congratulations on that aspect as well. Anyway, I think that's it for you then. Thank you. Beautiful project. And just one logistic question. Are we going through the whole, both Greg and my students in one shot, or are we breaking today? Sabina?
There's a break.
No, we are not. We're doing a break in between, and we discuss after this whether we need the first break, and then we have 2 more. But in between, definitely we make at least 15 minutes break. So that's the plan.
So let's just go through all of mine and then have that break.
Yeah.
Okay. Perfect. So my name is Simon, and I welcome you very much to the presentation. My project is called Plural Operations. The premise behind the project was to challenge highly dynamic landscapes in terms of economical, territorial, and geographical with regards to the residential you see in the picture. And in particular, how a hybrid housing can incorporate current climate shifts like the sea level rise. Due to the criteria I have taken, Den Helder as a site to explore these ideas with. Den Helder is situated on the coast of the Netherlands, and more importantly, it is at the North Sea, which acts as previously mentioned, highly dynamic landscape. Though its population is small, Den Helder, only around 55,000 people. It plays a global role when it comes to the oil extraction and to the offshore wind farms, along with the boat manufacturing, which is great heritage of it. In the next upcoming years, until like the 2030s, the EU plans to create the largest wind offshore farms, only a few kilometers away from Den Helder. So on the map, you see Den Helder, and then in red, the highlighted wind offshore farms, which get created. I try to work with the change the climate change will bring to Den Helder. So in this map, you can see one of the biggest risks which are coming with the sea level rise, and in Netherlands case, it's the floods. This map shows how the coastline on the upper part of the Netherlands is more endangered, where Den Helder lies, than the rest. And this is also a part I tackle in the project. So strategy rather than a single implementation in the urban fabric was my goal. I divided the strategy into 4 phases, which can again refers to the use of dynamic. Phase 1, you see these on the left-hand side, is responsible for establishing a flood defense, which incorporates sea level rise and the prevention for floods. Phase 2 could put a manufacturing hall on the map for local production combined with the local expertise, as I mentioned. Phase 3 ties everything together and build up the prefab parts on site. The last phase predicts that those changes could establish a broader impact. Seeing now on this axonometric, locate the housing where the issue is happening, and that's why I placed it on the coastline. In this isometric view, we can see more in detail how the housing gets scattered along the coastline. Number 1 shows the manufacturing hall in its industrial site in Den Helder. Number 2, 3, and 4 show the center from which the housing will connect with each other. In the map, you also can see the deeply rooted relation with water area to built area, which further on gets more focused on. So the blue is the highlighted canals, and the dark blue is the sea. A starting point of my whole thesis was the housing typology emerges out of the modular and highly technical typology of the offshore structure and the early housing concepts with modular systems in the middle. The starting point was to create more dynamic layouts with having in mind to create a system which can expand over time by splitting up existing layouts into rooms. I took this to create my own vocabulary of rooms already able to connect with each other, which you see on the bottom right side. The fabrication reusing is a rich part of the heritage of Den Helder and still a huge part of the local economy. So this influenced the project to look into manufacturing process, which you see in the picture. Laying out all parts of the assembled units, see on the far right. They consist out of 3 main parts: the steel frame, the timber primary shell, the timber secondary shell, and interior wood panels. In this animation, you can see the parts in its relation to one another. Each unit consists out of a primary structural shell, a secondary wood structural shell, glass parts, which function both as windows and doors in this architectural element purpose, and a composite out of wooden louvers and glass to allow more light penetrate the interior space. The form enables them to build different agglomerations according to the occupancy. So in the animation, it also shows you the agglomeration of these 5 units I created. And when it's finished, that is the last part of it. So all 5 of them are single rooms, and then they can later on be assembled. Now going from the rooms to the agglomeration which built the apartments. I focused on creating a housing landscape divided into private spaces, which are creating 4 general types of agglomerations, depending on how many people are living directly together. Furthermore, these are creating communal spaces up to 10 persons, having still their private space, but also creating a common sharing space. This leads to the connection to the public space, which perforates the whole structure parallel to the coastline. And now this housing typology, I'll start with the smallest. Left-hand side shows each apartment overlaid with the interiority, shown on the right side in scenes. So these are the interior spaces which created. On the bottom in white, you see out of how many and which parts they are created. The second apartments could highlight the outside space also with private and public expanding space. On the customization, these are connected by walkable pathways and a series of stairs. On the right-hand side, so you see the stairs inside, and also on the left hand, you see how the room expands outside on top of another component, which is walkable. On the bottom, again, here you see out of which components they consist, and on the right, the scenes they create. And I end up with the biggest apartment. It creates for large families and with a large living and entertaining space. This interior shot shows the relationship between the interior and the exterior to the sea, the outside. And in this scene, you can see the different configurations of building components. So now let's focus on the skylights. Then on the back left, there's a staircase going down. And in front of the image, you already see the same component, but it is a wood cover. So you can differentiate and individualize each component. The structural shows the apartments connect vertically through a planar surface, which depresses stress load on a connection and therefore throughout the whole structure. You can see that analysis shows there is a little strain and displacement force, which allows the building to have a good structural integrity and will withstand high sea winds and the rough waters when flooding. So on the bottom part, you see that's always connected with one another on a planar surface. And then I have my structural basic concept, which is always the metal shell, and then getting reinforced with the wood shell. Going from the single unit representing one room to the agglomeration of those into different sized apartments leads us to the next step of the configuration of more than one apartment into a communal configuration, which you see in the picture. Upon 10 persons and 4 apartments, I always build a communal configuration, which allows closer relation to one another, but still keeping enough private space. The plan is showing the relation of the build mass to the sea area. You also can see more about the whole strategy I talk about. The sea on the bottom part and the newly created waterways on the top, which are highlighted here. While the house sitting above the desalination pools, which feed into the homes with clear water. In the section along the coastline now, shows the height as the maximum it can be after wind analysis beyond 28 meters. The prevailing wind becomes too strong, and at specific location, the force on one hand would put too much stress on the structure, and the configuration also increases the quality of internal comfort for the inhabitants. The shot of the communing, showing the distance to the apartments to one another and illustrating the circulation that continues on top of those to the next apartment. So in the animation showing, you see the connectivity where you walk actually on top of the apartments to come to the others. You also see that the windows are the doors and therefore let light through and are creating these semi-private spaces when they are open. In this slide, I talk about what the landscape has to change in order to achieve a defense structure. So on the left-hand side, you see the infrastructure in its complete way when it's established, and then the different steps of sea level rise and how they are affecting the whole structure. The energy design, as previously mentioned, was one of the key indicators in the beginning for the design decisions. So I didn't went over 24 meters, because then the winds are getting too high and the internal comfort is decreasing. Also, this light analysis shows the decision I made of how to scatter each individual communal parts so that still lights on the bottom parts get more than enough and can use solar panels on top to feed a whole energy system. Whilst increasing sea level rise, I use this internal tunnels I created for the landscape and they incorporate each water turbine, which generates energy. And then more or less everything can work self-sufficient. And then I'm at the end, showing the finishing shot, the perspective from the sea towards the housing landscape, redefining how we look and create residential housing at the coastline with the premise of sea level rise. Yeah, and that's it.
Great, thank you, Simon. It's come a long way, really, quite impressive. All right, so any immediate remarks? I'm a little curious about, just as a side note, I'm a little curious about the rendering style. This whole kind of bronzish patina over everything, is that it because of the material choices? Does that have to do with sustainable materials and so on?
I think the material choice in a way is kind of like very simple decision. So you have in beige and brownish, the wood materiality, which I use, and then the black is the steel structure. So therefore it gives me already the rendering in a way.
I see.
I have a question. What I like about your project is that you use a modular system, which I think that the advantage of that is that it offers you an open and functionally undetermined system. So it offers an open system. The rooms can be used for different purposes as you wish, a kind of prerequisite for flexibility. But what is not clear to me, I saw that you mix steel structure and wooden parts, and you talked about an inner and an outer layer, if I understood it right. But in your renderings look as if they interpenetrate each other, so there is no clear differentiation between an inner and an outer layer, and it seems as the steel structure connects the outside with the inside, which might be a problem climatically and in terms of thermal insulation, comfort, and so on. So could you explain that a little more?
I think going off from this slide, it shows that the steel structure is completely holding the system structurally. And then I have a reinforced one, which is the timber structure, which actually makes then the break from the outside to the inside. And the inside only is this timber paneling, which is then the interiority. So we have actually this is not touching the outside and it's not connecting in the outside. So thermally it's separated.
And the metal surfaces that are visible on the outside, these are an additional layer of cladding, or how is it meant?
Yeah, so you have the whole component, which is structurally, and then it connects the interior parts, but actually the inner metal component is on top of these, so they are separated within a layer of isolation.
It's not so clear. Where is the thermal insulation?
On top of the interior paneling and in between those two.
Well, why is the steel so heavy? Why is there so much steel? Why is it sort of steel plate as opposed to skeletal? Just out of curiosity.
Yeah. I think the approach I had is that it's like each component connects on top of each other and then are connecting and building the structure as a whole. So that was the approach why there's so many methods.
So each unit has to be autonomously structural. Is that what you're saying? Has to carry load?
Yes.
And what about the wood on the outside, this horizontal surface of wood on the outside? How will you cope with the problem of rain and snow on top of it?
Okay, so climatically seen, it's a very interesting area. So we only have to deal with a lot of rain during a short period. And the wooden parts are impregnated. So therefore, it's also the layer which is getting rid of the water to drip inside.
So I could just...
Oh, sorry. Go ahead, Greg.
I was just going to say I like the steel structure very much in the sense that it reminds me of a lightweight stamped steel frame in a car or something. You know, that instead of building in steel components, I don't know how you would get it to the site, but I like the idea that it has a very kind of automotive approach to a steel frame. It is kind of odd then it's like having like a steel chassis and then a wooden car on the, you know, filling it in as the body. But I think it's a nice approach. I'd like to hear more about how you think that steel structure is stiffened and structured, and like how much it would weigh. Because if you could bring it to site in one piece or a folded piece like you do with a car chassis, it could be really interesting.
I think it's really interesting what you say, because it was a premise of kind of like developing it. So maybe in this rendering, you see already that in the back of the parts, the individual apartments get kind of like taken away from the manufacturing hall and get delivered as a whole to the site and then gets assembled. But I think in the design process I kind of like often thought about the automobile industry and how versatile it creates these different parts. So concerning to automobility, you always have this kind of like structural element, which is most of the cases the aluminium chassis on the bottom. But in a lot of new concepts, it's kind of like the kind of like structural element which holds it and needs to be aware of the stiffness of the whole engine. Gets incorporated more into the interiority, which I kind of thought a lot about it when I kind of like created these. So the structural shell, in the sense, it's kind of like, kind of like wrapping it up, the whole apartment. And then to the question of how it stiffens. So always have on the edges, in a way, these timber structure, which is a different timber structure to the rest, which can kind of like reinforce the moments on the corner which appear.
You proved it with Caramba, right?
Yes. And actually, when looking at the Caramba model, the initial outcome, when the first time I put it in, the displacement is very low because of the already quite massive steel structure.
Can I say something? Yeah. Well, as mentioned, this is all about modularity. Modularity was a great idea of the Industrial Revolution. It works fantastically well for industrial production. In the case of automobile, it still applies. In architecture, it was mostly investigated and represented in the 60s. In my opinion, the time when modularity was at its climax in architecture was 1967. Not 66 or 68. I think Moses Safdie, Montreal Habitat 67, which, by the way, your panoramic view recalls a little bit. Then if you go inside, your interior outlook reminds me of the house that Richard Rogers built for his parents here in Wimbledon in London. I think it is also 1967. So you're 1967 outside and inside. Oddly, but that makes sense because you are investigating a technology which in architecture was a very good idea, and not surprisingly, it was vastly investigated, both technically and aesthetically at that time. But this begs a question. If modularity was such a good idea in 1967, since the technology has changed so much, can it still be such a good idea now? Or the other way around, perhaps modularity was not a good idea in 1967, which is why back then it was not really, developed. It didn't catch on. So perhaps it is a good idea now, because today's technology with robotic assembly can do what couldn't be done 50 years ago. But my point is, it cannot be a good idea 50 years ago and today at the same time. So either it was wrong then, and it is right now, or it was right then, and then it is wrong now. In that case, that's a problem for you. In the first case, you're right. Second case, you're wrong. Jury is still out. I have no clue. You tell me.
But why, Mary? I don't understand. I don't understand why it's so black and white. I mean, why couldn't it have been a good idea then, given the technologies that existed and the means that existed and the social behaviors that were in play, and then now could be revisited in terms of new kinds of social behaviors, new kinds of materiality, new kinds of manufacturing processes? Is it really that binary that it's either?
I was probably overemphasizing my dichotomy, but when the Industrial Revolution came up with the idea of modularity, it was to make more stuff out of fewer components. Same components can be used in making different objects. Therefore, you can make more copies of the same item, thereby standardizing the repeatable component. You can maximize economies of scale. This is a great idea in 1880, and in architecture was probably a good idea in 1967. But today, if we project into the immediate future the idea of digital mass customization, perhaps we don't need to standardize each component that much, because we are no longer obsessed with the pursuit of economies of scale, at least in theory. Practice is another story. So in purely technical terms, now in social terms, it's a completely different idea. So I was just on the technical side. Social side, yeah.
It's not so unlike what Katera does by just saying the structural system will be timber, cross-laminated timber, but then everything after that structural system will be malleable. Let's not say infinitely customizable, but I see this project very in line with what a lot of very extremely large construction companies are trying to do in terms of rationalizing architecture for mass production. And so I think it's very contemporary in that sense.
Yes, because robotic assembly is now giving an idea of affordability and deliverability to modularity, because the assembly, which was the labor-intensive part, is now made by machinery. So it is a revival of that idea, but then it assumes that each component should be standard. Whereas today, it could be standard or non-standard as we choose.
Right, but I think to say non-standard and assume that everything is infinitely unconstrained is not to understand what non-standard production would be. I think that this is very much rethinking what architecture is, which is not every building is unique and built out of mass-produced components. This is saying architecture is mass-produced, and therefore every one of these things will be systematized, but somehow, unique in its details, or maybe even at the mid-scale.
Yeah, it's a very interesting question, but what I was expecting that would happen the moment the environmental analysis came in, and where I was, first I thought it's just my personal preference, but I think everybody else's, the discussion is pointing this direction as well. I was expecting that the moment the environmental analysis comes in, that entire assembly of these steel structures would then be differentiated, or the steel structure would remain the same, but all of the other elements that fill in would become differentiated in response to a kind of overall analysis of sun direction and views and water and so on. So I found it strange that the entire structure remains quite repetitive and homogeneous and mechanical, when I think precisely the update to the Metabolist project or to the unit-based system from 60s and 70s would have been that there's a steel structure that's load-bearing and it's mass-produced, but then there's this other system that's malleable, and we use environmental analysis, or we use in sophisticated algorithms, artificial intelligence, etc., in order to actually design those other systems across the entire assemblies, and this would give us some sort of more, like, on one hand, a system that's prefabricated and industrial, on the other hand, an overall community which is more biological, and where the relationship of an individual to the collective is different from of a kind of assembly where each individual unit is identical or repeated.
I mean, I think this is absolutely the wrong image to have on the screen, because it's speaking about something completely different than what we're talking about. But it's interesting. I mean, in these 67 units you did, that was a joke. In in all of these units you did, I mean, it's something strange going on here, because honestly, Simon, you had spent most of the semester talking about the social, political implications of this project on that little town, and the way that you wanted to move offshore workers and so on and so forth. There was a lot of talk about that, which has all kind of evaporated in the light of this project. The way you're presenting it now, it's still all there, I'm sure. And the reason I'm saying that image is the wrong image, because that image speaks about a certain kind of, speaks about certain tropes, luxury tropes in terms of interior design and so on. And I'm wondering why you sort of moved in that direction. But the project had a lot to do with habitat, had a lot to do with the 67 kind of ideal. Also that coming from metabolists prior to building kind of organic prefab situations for inhabitation in a rapid fashion, right? With rapidity. So that's part of this project, which you didn't really speak about, but I think is very much coming across. Are there any last remarks before we move?
Yes, I've been trying to talk since some minutes ago, and I am not so strong. I would like to say first, Simon, congratulations. Thank you for the presentation. It was clear, organized, it was consistent, and the different scales very well addressed. And adding to this conversation, the thing that I would like to maybe have brought to the equation is the new ways of living. And following also what Hani is saying about your own work, if just the understanding of the new ways of living would change the understanding of the growth and the addition of the different parts. Because you have been promising that it's dynamic, and it is dynamic at many levels, but not maybe in the way of living. Something maybe for a future understanding of what you have done, because it is in open systems. It could very easily have this condition as part of the understanding of the space.
I think this association of the unit with the room, which I understand that is the basis of everything, maybe for me is the part that you could have been thinking a little bit about, you know? I mean, if the addition of rooms is enough, or you need another scale, and what is that scale, and how could be achieved in a way? I think also that there are like certain things about dimensions and inhabitation, because at the end of the day, that is housing, no? And I think a bit of thinking about how we are actually inhabiting today, and how we are related to one another in small communities could have been fantastic. But also talking about, you know, as many examples in the 60s, where modularity was also related with the technology of the home and the house itself. You know, it wasn't the shell, it wasn't just a container. It was embedded within the general systems of the house to really provide a new understanding of how, in this case, how could we live today. And I think that it was somehow, I was expecting you to discuss a little bit, for example, distances, measurements, you know, everything. It seems that comes from the factory to the place, but I saw that there are like things like 8 meters wide things, you know. And then I think there is a discussion about distances, general systems, inhabitation, room, and many other things related with you know, being traditional problems of housing that could have been great to discuss.
Okay, thank you.
I think going back to just one quick comment on building on what Kivi was saying about the materiality of the skin. I mean, dealing with rising sea level energy is obviously a huge issue, and the potential to have incorporated that into the materiality would have, I think, done the project good to integrate different materialities into it and to deal with the obvious problem of where the energy is coming from. Also, rising sea as a problem, but also, of course, water as a resource could also have been something which could have been interesting to integrate into the project, and how you can actually work with the water.
Okay, thank you so much. Nice work, Simon. I think personally, I think it could have been more wood, less steel. But that's my own take. Let's move on. Thank you.
Thanks, Simon.
Thank you.
The obligatory "can you see my screen" comment.
Yes.
And the obligatory retort, yes, we can.
Okay, super. So for those of you that don't know me, my name is Kieran, and today I'll be presenting my thesis, hypermobility. So what exactly am I referring to when I say hypermobility? Hypermobility is an idea of my own that literally means mobility for mobility. It continues on.
Can you get into full screen, please?
It's in a browser.
Ah, okay. Sorry.
So this continues on the lineage of the 20th century, where individuals became mobile via their cars, and posits that in the 21st century, in a more epochal view, we will move into a hypermobile means of transportation, where our mobility becomes further mobile through other means. And namely, I'm referring to something I've designed, which is a hyperloop for the cars to accelerate them and alleviate congestion and excessive journey times between cities. So whether we like it or not, the car is very much a part of our future. There will be 900 million more cars on the road by 2040. And really, my approach to this is not to say, well, cars are bad, the auto cities of the 20th century weren't designed for the individual, and we're losing our sense of urbanism. But I think that in a capacity, we can use the car through this idea of hypermobility to solve a lot of its own problems by expanding their utility with what we already have. The reason for choosing the Hyperloop is simple. It is the fastest predicted mode of transport foreseen in our future. It is faster than commercial airlines and will be seen to replace short-haul flights. The idea is simple. We take the cars and the cars of the future, we invent capsules for them to prevent the succumbing to the low pressure inside the tubes. And then they are able to have access to this 1,000 km/h route between cities. Furthermore, in terms of the efficiency and the energy required, the Hyperloop only requires 3% of the energy needed for commercial airlines. what's important and in consideration of how this should be correctly implemented is that there has to be a way where this, in terms of its transport hub, it has to function as a junction and not just a station, meaning that we emancipate our transport and transitory means from typical intermodality and interchange. Here I'm illustrating that there is no change, and the idea is that you should be able to drive in with your car and proceed without any impedance for maximum efficiency. Where I will do this is in the state of California, envisaging it along the originally proposed route for the Hyperloop between San Francisco and the city of Los Angeles. As we can see on the right, the Hyperloop is much faster than any alternate means, 35 minutes compared to 1 hour and 20 for commercial airlines. Furthermore, the reason for choosing this state in particular, and more specifically LA County, is that it really is the platonic kind of figuration of an automotive city. LA emerged as the car did, and this duality of growth informed the urbanism of the city of Los Angeles, and is exactly why there is a very rigid and celebrated car culture there, and a very high level of saturation of cars within the city itself. The site for where I will build my hyperjunction, the physical manifestation of the idea of hypermobility, is within a certain distance of the center of Los Angeles, downtown Los Angeles, and it has been chosen simply because it's an opportune point to really exploit the different interface between other modes of transport to really extend this idea as far as is possible. Furthermore, it's an interesting site because it allows the river of Los Angeles to be reimagined in terms of a more urban and public view, that it seems will become less industrial and will become more walkable. The idea is to actually reinvigorate this with the invention of my hyperjunction and create these new walkable connections and enliven the riverside. We can see here in part how that will look. It's about creating these connections. It's about bringing the train in and creating this vibrant riverside that also connects to this new transport hub, my hyperjunction. Diagrammatically, we can see that here, that it's opportune as it is within close proximity of two large freeways, the railway line, and also this new walkable riverside connection. So here is where I kind of put forward my architectural argument that it is definitely trying to tackle the stigma surrounding the car with respect to architecture and urbanism. It's about understanding the relationship between our mobility and our individual selves, and offering a balanced, rigorous view of designing for how we can interface with the future of our technology without losing our quality of space and our sense of space from the individual experiential level. So I begin by explaining how we arrive, either by foot, by road, by train. I start with explaining the public walkable spaces and the arrival via train on foot from this location here. And beyond that, of course, it is easy to embark on foot and engage with the interior of this project. Beyond there, I will explain how we enter the actual interior of this project itself, the access, the grand hall within. This animation depicts the interior and the qualities I've been working on and the types of spaces that I really wanted to take this idea of a grand hall and make it the statement of this new transport typology that will be invented in the year of 2040. It's all about, my materials were chosen for the sense of iridescence with the lighting to create this sense of awe almost, and to make the statement about it being the future and somehow more grand and a step forward. And in plan, the view the space we were just observing is in the center of the screen here, this long promenade type space. And in the chunk we can observe how this looks and how separate circulatory spaces can connect with new commercial spaces implemented in behind the wall to also connect and create this kind of typical other additions that these transport hubs need with shops and commercial spaces and so on. with a different view, with a different type of lighting in the middle of the day. It also looks like this. Beyond there is something that's very crucial to the project. This is where I create the interface between the individual and the walking part of the building and the car, which eventually allows access to the Hyperloop. It's all about how cars can move from the freeway and into the central space where they are loaded and unloaded autonomously, or they proceed through as necessary. So for example, to list a few scenarios, you can arrive, pick up your car or deposit your car, and then take the train into the center of Los Angeles or go by foot. Conversely, you can arrive and drive to wherever. The idea is all about embodying options and facilitating this furtherment of transport moving forwards. Which is, of course, this space here. There are these ramps that connect the freeway to the entrance to the Hyperloop and the unload space. And here in part section, we can see beginning to understand the inner workings and the inner mechanics of this project. That beneath this area where you can get into and out of vehicles, there is an automated storage system that unloads cars and stores them within the tower. Here, if you choose to continue on foot or to connect via train. And here's where it's an opportune point to actually explain why I'm working with the year 2040. 2040 is the beginning of the decade where the car of the future, the autonomous cars and the electric cars, will really begin to dominate the market forevermore. 57% of cars sold will likely be electric and of at least level 4 autonomy, meaning they're fully autonomous but still have the option of manual control, level 5 being beyond that with no manual control available. And in a closer view, I can explain here, for example, exactly how the autonomous part of this project handles the car loading and storage. One for arrivals and the other for departure, one lane going beneath. And finally, this idea of hypermobility, the actual hyperjunction itself. So we've moved through the grand hall, we've seen the unload space, and finally we finish with the heart of the project in many ways, which is the machine that actually facilitates this branch of hypermobility. It's about transitioning and interfacing our world with this new hypermobile world and supersonic speeds that are available with the Hyperloop. It's not just also the Hyperloop, it's also a means of it's a geothermal power plant. In section, we can begin to see how all of these things come into play, that it's the machine that really makes the project work technically, aside from the experience of the space, is that the cars are loaded into these capsules. They then enter these, what are called turbomolecular pumps, where the air can be removed. These capsules can then proceed into the Hyperloop. And alternatively, when they arrive, the inverse is true, and the capsules are stored beneath. The road in the middle here is actually a connection to the other freeway that isn't readily apparent in the other exterior renderings. In an explosion, we can begin to appreciate the inner complexity of this part of my project. The hybridization of the idea of producing energy in tandem with where it's needed was a very poignant concern of mine. The reason geothermal is viable is because in the state of California in general, for the fact it's on the Pacific plate, is a viable option for geothermal energy. At a depth of 7 kilometers, we have around 200 degrees Celsius of geothermal fluid available. And then more technically speaking, we can see how this geothermal fluid is circulated. It warms up the circulating water into the steam, which will then power the turbines. And in doing so, generate power via the generators. The steam is then circulated up into a series of absorption chillers, which uses that remaining energy to provide cool air to the rest of the building, which is also illustrated here in the diagram. There are a number of loops available. The net sum of this is to provide this passive, well, it's a mechanical way of using the remaining energy to actually cool the more walkable interior spaces of this project and also fall down into the other spaces below. Also, the prevailing wind direction will also enter through the side of the building and also provide cool air and hopefully pull through via these earth tubes I've added to provide the pressure difference on the other side of the hill. Structurally, the project is also very interesting because of its size and the fact it's within a hill. A large chunk of it will be removed and replaced with an artificial green roof. Other parts are dug out of the soil. So we have two space frames, one to support this new roof, the other to support the ceiling and the span along the front of the building, as well as a ribbed structure to support all the cladding as an example. And in analysis, we can see that the utility of these structures is viable as well as the displacement, starting with the space frame for the green roof, the green roof itself, the other space frame to support the openings and the structure over the hyperjunction, and then as a whole, this part of the structure, which is reinforced concrete for all of the columns and the ceilings. And in section, I can finish by summarizing and visualizing the connection with these different types of spaces, moving from left to right, from walkable into the interior, into the car, and then eventually into the Hyperloop. So really a strategy was to actually frame the project in terms of its pacing, that as you proceed through, you become faster and faster and faster. So for example, the different chunks, the unload, the hyperjunction and the arrival and the interior connection for the walkability. And I finish with the combination of all of my interiors and exteriors and systems as a long video. Thank you.
Extraordinary commitment in this project, Kieran, to your language and your commitment to the idea. As to its success or failure, I think that's for us to discuss. Anybody want to start while the video is running here?
Well, I can second that. I mean, it's not very common that one sees a presentation which is this eloquent, technically, visually, and verbally. So it's real pleasure to follow, and so that's I think that's important to state. So you can be really proud of it. Then let's see how your video goes and discuss other aspects of the project. Maybe you could say, like, once the video is running, just say a few words about the experience. That you mention it every now and then, and you discuss your choice of materials and the effects they produce. But can you describe a little bit more the experience that you are after? Let's say overall, in quite general terms.
Generally, I think if I were to use a word, I would to say compelled. I think it has to have, and what I was going for was a certain strength of experience through the atmosphere, but also the geometry. I spent a lot of time, which I think is apparent, for really trying to figure out the tectonics and the connections between all of these elements. Because when you deal with projects of this scale, what I've discovered is that it tends compositionally to look like a bit of a mismatch or a montage if you don't appreciate these things. And whether you agree to that is, of course, of your own concern. But for me as a designer, it's something that is very important. So the flow and the connection of all of these elements, I think, is also plays a part in that you can trace certain shapes and see how things connect and see how the function almost that's very specific to it. For example, in this space where the cars unload, certain shapes carry on and then connect and then respond to each other. And that also in turn does affect the way the light and the air moves through the space and where you get reflections and where you don't. So that's really how I approach it. And I think I've been successful in at least creating that kind of experience personally.
I would like to ask you something, Kieran. First of all, thank you and congratulations, because it's a beautiful and full of imagination illustration. And that's my question. How much do you want to be like a more in the world of illustrations, or you would like to really address a reality? And if you are aware of this, and it's your decision to be in that point, which I respect totally. So it's more about what do you want to really do and achieve, and where do you want to be, in which line?
But I think technically it works if we're talking about the sense of reality, but the fact that we deal with these ideas that are very orientated in terms of depicting a future, the illustration and the way it's presented to almost seem glossier or too nice to be real, I think is a part of it, to show that somehow when we look to the future, I've always thought that the sense of realism has to come from more of a positive view than necessarily a negative one, or a bleak future, for example, which is why I do focus a lot on the representation and the diagrammatic.
But coming back to previous projects and previous comments as well, there is a sense obviously in here, which is not a criticism, and don't take it as a criticism, a sense on here about a very cartoonish in the tradition of cartoons and comics and science fiction being depicted in there, the interiorization of spaces, the repetition of offsets as something, that supposedly is structural, with thicknesses and darkness and artificial lights. All this world obviously refers to, and the lack of, and most importantly for me, and the lack of a global comprehension. So everything was like shown in fragments, and with the fascination for the language of the engine, because I was confused in certain moments if I was looking at a car engine in detail or a building. And there is this fascination that I would like you to talk about, because I think it wasn't spoken, and I think it is crucial and is determining, most of your architectural moves. You talked very much technically about it, but I would like you to talk about this, have a look to that, They're looking like pistons, and bulbs and elements that are coming out and out. I think something about it would be great to hear, your own critical view on the architectural languages that you're like inheriting from this world that was like depicted at a certain point.
So the way I approach it is I do tend to look at things as each individual component and make them work functionally, but I also extend the use of the word function to mean more than mechanical. I do see the way we perceive space, and here, for example, the way the light comes through, I see that as something that can be functionally obtained. So proportions, and then the way I have my edges is usually done in correspondence with that kind of way of looking at it.
The thing I'm trying to reconcile is not the scale, but the primary mode of experience, because thinking of like the Boring Company and the Hyperloop, it's a seamless proposal where you almost like a very efficient ferry experience, where the car goes onto a machine or into a train, and you assume that the person's going to stay in the car and be entertained and communicate and work. And I think your ambition is to have architecture be part of that conversation and to scale the experience to a station. I mean, where you have that like Grand Central type, or like, Gare du Nord type experience of a vast civic space. But when I look at the car, the constraints put on the cars, it seems like you're trying to pack them in. So it's not like the experience of kind of a 3-freeway overpass where everything's connected at high speed and seamless. It's much more like a 19th century train station. And so I'm just wondering, is the scale meant more for a pedestrian or for an automobile, and at what speed do you think it's experienced? Because that's the thing that I can't reconcile. It's the one major question I have.
The scale itself is actually derived from the thing I designed first, which was the machine to actually facilitate the car transitioning to the Hyperloop. And then the second constraint on that was the fact that I wanted to put it inside the hill, and I was already very close to entirely filling that. So when we towards the end of this, or if I refer to here, for example, in the section, we can see already how big this thing is. So I thought that kind of sense of scale is about, because the faster you can go, the larger the sense of scale is, and the smaller it seems almost, because the faster you are going. So that's kind of something I wanted to extend in this kind of statement about that, because it's faster, it has this grander sense of scale.
But is it, because I just think of it as an primarily automotive experience, but in fact, what you're saying and what it's looking like is it's a little bit like the scale of a port, like a multimodal port, where you're taking things off of a truck and putting them on a container ship, and things are getting lifted and hoisted and moved and racked and stored, and it's a little bit about the, like treating the car like a container in a way.
Yeah, sure. But that was something I'd looked at since my my pre-thesis, because the commercial kind of transportation networks for delivering things and hauling luggage and whatever else they may do is somehow more efficient, more autonomous. And for this idea of shortening journey times, one thing I always have is the example of the airport is that, yes, the plane is very fast, but the queuing and the waiting and so on was something I wanted to really focus on avoiding.
I have a curiosity.
Yeah, sorry, go ahead.
First of all, evidently, we all agree this image is extraordinary, and the enactment of the experience of a highly mechanical space for the automobiles that are coming and going, and all this vacuum cleaner technology, which is pipes, and it's like being, a tourist inside a vacuum cleaner, which we mostly cannot do in normal life. So this is quite unprecedented. But curiosity, I'm certain you have already been asked the question many times and you have already made answer. Assuming that this comes to fruition at the time when the self-driving car is ubiquitous, assuming you get to the station with a self-driving car, which you can drop there, then you take the train, and at destination, you can take another self-driving car to go wherever you need to go. Why do you want to carry a self-driving car with you as a shuttle, in the shuttle, all the way? What's the advantage of carrying this, tons of metal all the way around you? Of course, now in the COVID environment, we all would like to do it, but we may assume that in 20 years, that may, we hope, no longer be necessary. So the idea that you must keep a shell of a mechanical protective environment around you, your car, perhaps in 20 years, we will not need that anymore. So what's the rationale for carrying your car all the way with you?
I think it's more a statement about personal autonomy than it is public. Is that on the one hand, this is publicly available, but somehow the narrative is more interesting when in the future, for example, because I know most narratives are about everything becoming a totally free source and open. And I was more interested in the inverse of that, as I said at the beginning, and why I chose Los Angeles is because it's very much more about individual autonomy. If we compare it to Europe, it's got a much lower level of available public transport. There is less of a culture for it. Most people there own multiple cars. Contextually, and therefore with respect to that, in this part of the world, it perhaps makes more sense than it does in other places. But also to lead on from there is not everywhere is accessible via our main modes of transport. And it can be annoying or complicated to traverse any network via a number of modes, and the primary focus when I refer to hypermobility is purely about streamlining with one system. And I decided that the most attractive way that could be posited, rather put to people, is through saying you can take your own means of transport, because to a lot of people the car is very important. It's a sign of growing up, it's a sign of personal autonomy, it's something to have, it's something to behold. And I don't think that will really go away when we have autonomous vehicles or electric vehicles. So it's really about furthering that conversation and engaging with people in a broader context.
So your idea is that in 20 years, when we all have a self-driving car, you will still have a symbiotic relationship with your self-driving car to the point that even if the car is driving itself, and so you no longer have the identification of the driver with the car, you still don't want to separate yourself from your own car, as you would from your dog or your cat. You want to keep it with you all the way because it's a part of your life. This is certainly the case today. You expect that in 20 years it will still be that way? I have no clue.
But if you accept his premise, like I think we can discuss whether what will become of the car in the future. But if we accept your premise that the car, ownership of a car and having the safety of a car in the era of pandemics, and if we just accept that as the premise, then this is what I was asking earlier on. It sounds like you're trying to you're citing on you're on the side of the individual experience that makes people love the car, and that's characteristic to Los Angeles. But vis-a-vis that statement, then I find it as beautiful as it is. I have to say that when I looked at some of these renderings, what came to my mind was a friend of mine who travels even more than I used to, and he would always say that as long as you think your luggage, it's fine. And it makes you, when you look at these renderings, it makes you feel a little bit like your luggage, like you the moment you enter the system, you're being processed, and you go through this process, then you spat out in the other end. And if the premise is to somehow maintain the individual freedom, individual ownership of the vehicle, etc., then how do these design decisions, kind of relentless, the scale, the repetition even in architectural detail, the glossiness, how do all of these devices that are organizational, atmospheric, formal, etc., even representational in terms of like references to cartoon culture or anime. I mean, how do those decisions work towards that effect of freedom, individual choice? I mean, that's a really, really interesting discussion and challenge.
Mm-hmm. True. I think that having these things somehow does provide that personal experience, or at least goes in some way to give you something to engage with the complexity and the volume of it. I think it sometimes we overlook it, but the ability to draw the eye in space and engage with people visually is still, for most people, their primary means of communication and interface with spaces. And I think sometimes that's forgotten, and it's definitely something I'm trying to embrace, that I think the strength of space is what provides the personal experience, whether the strength of space is defined as tectonic or atmospheric or whatever. I mean, I was going for a combination of many.
Okay, well said. And
please, just the last question. What we see here are columns, yes?
Mm-hmm. Yes.
And why did you design them like that? Does that have a certain reason? Or some of the columns are cut somewhere, I saw it here.
Yep.
So it's just a kind of art deco element, or why did you decide to design it like that?
To define it like that was about affirming and reinforcing this idea of this continuum within that space. Without them there, it kind of felt strange, and the end of the space in the ceiling didn't flow or define itself as well, which is why they're there. Because they also still separate this space, the space we're looking at now, from the grand hall space. It's also about defining the differentiation between these two spaces, as we can see here.
Mm.
When you are on this side looking down, they still provide the perforation visually to how obscure the space. That's why.
But that's what I mean with these elements we see now. Yeah. Okay. Thank you.
May I ask another technical question? You have this huge concrete structure you showed before, and above that you have another space frame. Why do you need that space frame?
The second space frame is because if we look at the section, this element here, to actually build this thing inside the hill, this section between here And here, the entire hill would likely have to be removed to obtain the height because there is not enough physical structure remaining. So it's more efficient to use a lightweight space frame type structure to hold up this new artificial green roof that replaces the old hilltop.
That's okay, but I wondered why you took a Mero system, which we could say now is a very old-fashioned system, but it's a regular modular system, and with the robotic means, so we can do different things. That's why I wondered if you did it for a certain reason.
It was just about, because of the span, it was about just finding something that would work and that I could be sure that would work because of the span.
Okay, that's clear.
Have some kind of recognizable element to show that it works.
So Kieran, everyone thinks your name is Alexander Ahmed because that's the name on the screen there, but it is Kieran. And you know, Kieran, I just want to say that having watched you go through this, it's fascinating to see how obsessive you are with sort of the on two fronts, and this goes back to the first comment. On the one front, with this kind of engineering sensibility, but kind of engineering in search of some kind of new ornamentalism for sure. It's a very strange approach, but it produces some pretty powerful outcomes. What's interesting to me is I sometimes look at your work and I wonder, well, are you really going down the road of illustration? Is this really a DC comic sort of, you know, movie set for some crazy sci-fi film? But the fact of the matter is you really are, again, as in Leone's case, kind of working as an architect, you really are obsessively architectural about the project. And it's really interesting because your whole notion of putting pieces together to flow, having to introduce a space frame, having to put it in Los Angeles, and also, quite frankly, to Mario's point about, I think we are moving towards more and more wearing our cars like our clothes, because I think that, especially in the post-COVID era, as you mentioned, now all of a sudden, nobody wants to share cars anymore. And I'm not so sure that's going to go away in 20 years, but I think the idea of owning your space, let's say, and the car becoming symbiotic with you, with the space you move in, is interesting. I actually think less DC comic and more Paolo Solari is really what makes you an architect here. But it's hard to sometimes see that but if you look at those sections, they are obsessively architectural and very, very interesting. And I have to applaud you for your commitment and your work. So thank you. And we move to the last of my herd, or
Okay, can you see my screen? Okay, do you hear me well?
Yes.
Absolutely.
Okay, perfect. Thanks a lot. Okay, hi everyone. Thank you again all for joining us today. My name is Jan, and I will be closing today's presentation of Hani's studio. I'd like to introduce you to my diploma project, Utopian Factory, which is located in Talvivaara, Finland. So the Utopian Factory outlines an alternative to the current model of industrial manufacturing, leaving behind an excessive production and environmental exploitation of the last 150 years. It embraces key concepts of pre-industrial labor, such as highly skilled workforce, sustainable scale of resource harvesting based on a local availability, clustering into self-sufficient production hamlets, and avoiding overscaling the production rate. With somehow an update with the current possibilities of Industry 4.0, such as automation that enables mass customization and the phenomena of digital craftsmanship. So when we speak about industry, there is hardly more problematic industry right now in regards of resource exploitation and the environment devastation and recently the job loss caused by the automation than the industrial mining. One of the biggest industrial mine in Europe is located in Finland, in Talvivaara, which is in Kainuu region in the central Finland. At the same time as the mining industry is quite big in Finland, they right now have 52 active mines, open pit, but also other types. The counterbalance of this industry is the sustainable forestry and the timber production, which is also quite big right now. Has been major in Finland for quite some time. So Talvivaara mine could be considered as somehow a definition of what's wrong with the current industrial tendencies. This is the site of the refinery of the mine. Right now they're using acidic solutions to first mine the ore, which is a very dusty and polluting causing method of excavating. And they're using acidic solutions to basically get the nickel out of the ore, which cause huge problems with leakages. So therefore I propose a remediation strategy, some sort of a future for Talvivaara, which introduces sustainable forestry and which utilizes also hyper-accumulating plants for sustainable nickel extraction, as well as tree farms, co-owned tree farms to remediate the devastated land, as you can see in the north and the south part, instead of the original acidic heaps. At the same time, my project, the factory itself, is located at the north part of the site itself. I also introduce kind of a long-term strategy to replace the refinery into a district micro CHP power plant. CHP stands for Combined Heat and Energy Power Plant, to provide for district energy in the radius of, let's say, 20 kilometers. The project framework, so the kind of global approach to it is that I'm using, the first stage is to remediate the area with the phytomining. That means that there's a special species of plants that is able to suck out the nickel out of the soil. Then a production, so kind of as a part of industry paradigm shift, a new system of sort of a sustainable timber farming. The factory itself, which is my project, is basically focusing on processing the wood, the material, and also on fabricating a prefab mass customized elements. And at the same time, it serves as some sort of a didactic tool for this kind of a new era of blue-collar workers turned to digital craftsmen. So the project facility is located on the north edge of the now disused mine. The goal of the master plan is to embed certain fragmentation following the idea of Machi's group forms, but also drawing inspiration from coastal cities in Italy, which are blending with the environment and with the coast shores. The facilities consist of automated processing units and also units which are based around retraining of the miners and other workers. As I was mentioning before, I invoke some sort of a long-term strategy. So as a part of this long-term strategy, I try to cover phases for different development phases of the project in the scope of 7 to 10 years, and also over to the long-term goals projected to 20 plus years. So those phases are remediation, in which basically we establish new citizen-owned land strategy and terraforming efforts. Then the research and development, which is some sort of a getting from the blue-collar work to the idea of digital craftsman. And kind of the long-lasting phase, which is the production. So basically, the project sets a trend for a slow, local, and sustainable production and self-sufficiency. My geometrical language is investigating an interlocking logic. It draws inspiration from classical carpentry joining, but also from Japanese joinery. But it supersizes it into architecture scale of building elements. By following same rule set of this interlocking, we can achieve and produce non-standardized artisanal elements which are compatible between each other. We can achieve this by revisiting how the CLT, that's the material of choice of my elements, how CLT is produced. So right now, the current production process of cross-laminated timber, as much as it is already automated, still relies on sort of a 2.5D plotter-like processing space. So my project proposes full integration of robotic assembly line, not unlike the automotive industry. Using high-precision robotic manipulators that operate in 3D space, we can achieve more complex prefabricated construction, compositing, interlocking, load-bearing mass timber elements with hollow elements that can embed MEP based on the needs of the desired function, as you can see on the diagram on the right. Using this approach, I started to hybridize an architectural archetype. So this system that I shown you previously was architectonized through introduction of circulation, interior and exterior niches, openings, entrances, and embedded robotic systems throughout the different scales of the pieces itself, and therefore blurring the traditional understanding of building archetypes, where we no longer talk about a simple division between a floor and a slab, for example. The interlocking tectonic language allows for a certain degree of mass customization. So therefore, the idea is that if now we're looking at a simple 2-floor short-term living unit, so the idea is that you can mass customize the interiority, the surface treatments, but also, for example, since CLT is millable, you can, based on the solder analysis, you can mill out certain aspects of the exterior shell to include PV photovoltaic panels. My housing, so basically the housing unit is a part of a larger cluster. It sits on top of a workshop, which also serves as a foundation. So what I forgot to mention in the beginning, the issue with open pit mines, as the one in Talvivaara, is that they tend to collapse over time. So one of the major phases in the beginning is to basically use the structure to stabilize the ground, the slope of the mine. Therefore, I introduce in the first stage, in the stage A, a slope bracing. So there's first excavation, then the deployment of bracing scaffold, and the workshops, which are under number 4 over here, work as some sort of workshop foundations. In the phase 2, the workshop provides storage and research spaces for the ongoing research into phytomining, but also the network of connectivity bridges is placed. At this stage, the area is still not completely suitable for even a short-term living. And in the phase 3, the remediated environment allows for deployment of short-term living units and other amenities, as you can see under number 8. So at the top, you can, in this kind of explosion chunk, you can see the interlocking housing unit with 2 floors and the embedded circulation, which is actually embedded on the side of the foundation, which also holds or envelopes the interior workshop, which is this kind of primary private collaboration space between the blue-collar workers that come to the site to retrain to become these digital craftsmen. This cluster of workshops with short-term living is deployed on the in my site plan is deployed on the west side of the mine, and basically it works in 2 phases. So as I mentioned before, firstly there's some sort of a automated phytomining extraction of the nickel from the mine itself, and over time, as the environment is being remediated and fit for human occupancy, you can deploy the housing units and other amenities, and the workshops basically become the foundation becomes the workshops. Structurally, the short-term housing and workshop district was evaluated for the structural feasibility. As I said, I'm using CLT, which stands for cross-laminated timber, which is being produced on site from the local resources. And the CLT has high structural capacity and therefore proved to be an efficient material of choice, complementing somehow the structural viable tectonics of the geometry of the project. With the structural simulation, the structure achieved total displacement of 2.2 centimeters. And since the whole structure is made out of this very massive mass timber pieces, as you can actually see in the utilization, it is somehow underutilized, which just proves the validity that, yes, if you put the strong massive timber, they probably can withstand way more load. So the transportation of felled trees utilizes the artificial water channel, which is introduced to the site. The reason for that is twofold. A, for, let's say, non-polluting, zero energy wood transportation from the 2 new timber farms located west from my site. But at the same time, these water channels are basically how we can prevent flooding the mine itself, because that's also another issue of disused open pit mines. So as I said, the river is used for delivering the wood to the processing zone, which is located in northeast of the project site. After quality inspection, cutting and drying, which is done mostly automatically by the robotic line, the wood is delivered by autonomous cargo vehicles to either Eastern Automated Facility for cross-laminated timber production, located over here, or is formatted as wood planks and delivered to the retraining workshops in the central and the west part of the project. Regarding my energy, I tried to introduce some sort of a compensation strategy. The total surface area of the project is around 6,000 square meters, and therefore we're utilizing quite a lot of that surface to gain a photovoltaic energy. We get, with those 6,000 square meters, we get around 1 megawatt hour a year. We're not excluding the winter, because the winter is still giving us at least 1/5 of the overall energy, but clearly most of the energy we get in summer, which is actually quite suitable for the whole framework of the project, because the idea is that there's also this combined heat and energy power plant, and these 2 systems basically complement each other. So in winter, we're using most of volume, while the photovoltaics on the surface of factory is operating only on 5%. And in summer, this basically switches. And this way we can provide, between switching these 2 systems, we can provide for overall energy demand. Also, at certain times, we can have such an overproduction of energy that the idea is that the CHP plant can deliver a district heat energy to, let's say, a radius of 20 kilometers, which is already powering, let's say, 6 to 7 towns in the vicinity. In here, we have the central part of the project, which shows the automated CLT production zone, just a piece of it, and different types of spaces that accommodate for research offices, but also larger auditoriums. The circulation is differentiated into 3 major streams. The main circulation axis, which you can see on the diagram A, penetrates the project and connects the east and west exit road out of the mine. So basically point 01 and with 02. The pedestrian circulation, which is diagram B, showcases the housing district, but also connectivity for pedestrians, interior and exterior, throughout the project. And lastly, there's the material circulation, starting with the wood processing unit, coming down to the 2 units for wood storage, and either delivering the wood for the district over here or keeping it somehow in-house for the CLT production. In this cross-section, we can see one of the larger workshops which have deployed high-performance robotic arms. These arms are then used for manipulation of bigger pieces of timber. This is the interior render from that space. The whole idea is that basically in the future, the robotic arm will somehow become this next open source 3D printer. So let's say way more omnipresent than it is now. Here we have the shot on the bigger workshop that you saw the interior from. On the left side, you have the auditoriums, and above you have the wood storage. So again, on the west side is the housing district, short-term housing district, and the northwest side is basically where the wood comes from those 2 areas of timber farms. And finally, I'd like to thank to my family and for their continued support and collective of the whole studio and the teaching staff. Thank you.
Great. Another super ambitious project and quite well executed, Jan. Beautiful. I guess, but there's lots to talk about, I'm sure. So we'll go. Greg, what do you want? You want to say something this time again? Something contentious?
No, I'm not trying to be contentious. Sorry.
Where do you live, Greg? Where the hell do you live? Bel Air?
Bel Air. Give me a break. No, on this one, I kind of thought Kiwi should lead this off and just, I'm sure he's going to give it a stamp of approval, but as a Finn, I'm curious what he thinks. I mean, it's what I love about the project, Jan, is its prototypical ambitions and its geographically and national specificity. I think it's great. I think it's really great. And it doesn't suffer from any of some of the other questions people had about where the language lands in terms of being futuristic or nostalgic or anything. It seems incredibly contemporary and driven by the cross-laminated timber vocabulary. And I'm just curious if Kiwi even thinks this is in any way regional.
No, yeah, it's okay. I'm happy to comment. I think it's beautifully executed project, and yeah, I mean, maybe I can bring in I mean, I worry about being too specific then in comments. I mean, for this kind of project, I really like in the bigger scale of things the way you build a project and the simple statement of using Japanese joinery scaled up. I wish I would have seen more exactly how that works. I remember looking at those joints often and wondered whether you could really do, because they are architectural. It looks like the grain of the architecture, geometrically speaking, is good for cross-laminated timber. I mean, the surfaces aren't too expansive or large, and folded structures work really well with cross-laminated timber. So I think the architectural vocabulary that you've chosen, it's not completely novel, it's contemporary, and I think it's appropriate for this. Then, I mean, I almost didn't want to say it, but quite specific comment was like, you spoke so much about the economic setup and Talvivaara and so on. I really was wondering, like, what would be the argument of doing this in Talvivaara, economically speaking? And we don't even have to, we can just take it as a granted, but I don't know how one would convince them that this is a good idea. Why would you not just put this factory anywhere? I mean, that area of Finland is basically like Alaska. There's just space and forest. So I don't know if there's any specific incentive from the pit mines or something that would be the geographical features or something about the mine that would actually lend itself for this type of construction or operation.
Before you answer that, Jan, I just want to say, Kivi, thank you so much for the Finnish accent and the birds as a soundtrack to this project. Yeah. It's absolutely on the money.
Yeah, it's
right?
Yeah, and then I was looking at little things like you actually have the best Finnish-owned CLT factories in Austria, in Ybbs. And the production line is 16 meters by 3 meters long. I was trying to look at your drawings, like, where do you have this type of facility, and is there something in your drawing that would show a kind of change in scale where you go from these large hall-like linear spaces, which could be on the right where it says CLT production, and then you go into these when the CLT gets cut up, and then you would have robots add finer detail. And that's actually something that really is missing, that these factories, they're able to use saws to cut. That you can cut a line at an angle, but you don't have 5 CNC mills doing details. And to add that kind of ability, actually, in the world of CLT factories is quite a contemporary thing. If you could do what you said, automate the factory in a kind of Tesla manner, where you could then, some elements could receive finer and finer detail from more sophisticated CNC milling. So I think all of that is quite convincing. But this Talvivaara argument, I didn't quite understand. Is there something about the landscape, the geography, or the setup that would specifically, other than it would be a beautiful, like a poetic thing to do to a terrible mine?
Yeah, for me, my project, I really wanted this project to be some sort of a, let's say, critique on current overexploitation, industrial overexploitation. And while I was doing my research, I found out about Talvivaara. And for the record, I didn't know you're going to be on the committee. But yeah, I found out about Talvivaara, which was also in the ongoing research about the timber industry. Because as I guess it's quite clear right now, everyone right now working with wood in architecture is kind of buzzword. Everyone's talking about creating skyscrapers out of wood. So I think we can expect that there is going to be a kind of a race in demand for timber, construction grade timber. So that kind of led me to the site. I don't claim that the Terrafame, which is the company that owns the mine, would like this project. No, because what I claim is maybe for the future factory is actually leaving the idea of the Industrial Revolution and maybe coming back to the kind of idea of a pre-industrial hamlet. So maybe it's time to, or will be time to slow down a bit and maybe say, okay, we don't have to mine 10 million kilos of nickel per year, but we can go with less if we combine it with different industries and resources, such as sustainable forestry.
Okay, but I'll add one thing before that's specific. I think it's clear that the choice of site is basically a cultural argument, and your project makes its point better because it's in this contagious place, and it's well chosen in those terms. And I think that always matters in architecture. I think you mentioned this tall construction. I think your proposal is realistic and good for CLT because it's not tall. It's actually, the latest research is something that the CO2, anything above 8 floors no longer, like, it competes very well with concrete, or it starts to be equal in its carbon footprint. And so there's a little bit of naivete that's going on. For example, if you speak to engineers, they would say, I don't know what Klaus says, but they say that CLT height was invented to sell gypsum, basically drywall. Because at least in Scandinavia, in order to do a tall construction, the fireproofing requires like double the amount of drywall over the CLT, which makes it not a very sustainable way of building in those heights. But a horizontal structure that doesn't have those constraints is very, very good. But I think it's a better typology. The typology and the formal language you've chosen is really good for the material.
Thank you.
I have one short question. Is the nickel mine a precondition of the project? I mean, does it have to be closed down in order to realize it? Or should it be a parallel action? Or what was the hypothesis?
So the thesis is that in a way we do close the mine in the sense of the scope of how much they harvest, but at the same time, and we engage in terraforming activity. Well, we can call it terraforming activity, but at the same time, as I mentioned, there's a new mining technology, which is not technology at all. It's actually using plants to mine nickel, to mine metals from the soil. It's not as productive as a traditional mining, but it still works. And at least from what I've researched, it's starting to be considered as a quite viable alternative for nickel extraction. So yes, to answer your question, the nickel mine as it is right now would be closed, as in the refinery that would be repurposed into PHP, but there would be still ongoing nickel extraction from the soil with less invasive technology. And at the same time, the architecture would come in to start to somehow repopulate and remediate the area, because it's not so clear from the satellite image, but it's quite a desolate land, unfortunately, as it is right now.
Okay.
So, Kiwi, I think you're right. It makes sense to use timber, especially for the horizontal members, but it also makes sense to create hybrid systems where you mix up with wood and steel or wood and concrete. Yeah, and use the materials which is the best for the situation there. Mm-hmm. But my question to you, Jan, still is, we talked about the surface of the wooden structure. I think if you leave it as it is, so you have to paint it every 2 years.
Yeah. We discussed together certain case studies, such as the surface coating, which was used, for example, in Parasol in Spain. At the same time, as you can see from some of the renderings, I was thinking of utilizing charring. So it's kind of traditional. It's coming more from east, from Japan, but I can imagine that the wood would be actually charred to create a protective layer. But obviously it would have to be a composite. So it wouldn't be completely just one massive piece. But right now, also when I was doing research, I found out that they're starting to create a hollow CLT panels, which basically can accommodate for insulation and other things.
But this is gonna go very specific and nerdy now, but I was looking at your like these kinds of structures, what you would do is you would have the CLT is at thickest 400 millimeters. You would have, and at finished climate, 200 millimeters is sufficient with no insulation to insulate the building fully. And if you want to have air for insulation and technical systems, then you put two 100 millimeter surfaces inside and out. So you basically do those things that seem to have thickness would be hollow, and there'd be air and as insulation, and you wouldn't actually have to add anything. And then we're running an experiment on the surface treatment right now, and the best thing we've found out, but I'll tell you in a half a year how it went. But there's an oil called Rubio monocoat, which goes to the cell structure of the wood. So what you do is you sand these CLT surfaces, then you treat them with a color tint, and then you treat them with colored oil. And the key is that the oil makes no surface like a paint, because otherwise you would have to, in a couple of years, something goes wrong, you have to remove the paint and repaint it. But you need something that makes no film that actually goes in the wood. So this oil or traditional tar, actually like the way that you would tar boats, that was the second best choice, but it actually smells beautiful, but a little bit too much. So, but I think the issue is how to waterproof this so that you retain the breathability of the surface, that you don't turn it into a plastic membrane. Because the great thing, we have another project which is in flooding danger, and the great thing about the wood is that you can get wet, but it will dry like a boat, and it will weather, but it won't get destroyed, as long as there's no insulation or plastic membranes or anything like that. So.
Yeah, and the energy supply concepts are very well thought through. But I have a question regarding, I'd like to hear your comments on, it's a very fragmented geometry. And in this part of the world, and also the orientation doesn't appear to, it doesn't have a specific orientation. So in terms of the basic fragmented geometry and the energy performance, how did you approach that?
Right, so the orientation was, it was somehow a negotiation process, because clearly I was trying to deal with the bracing of the slope. So the site is quite complicated as it is. So I had to take that in account. So it was a combination of let's say, orientation and just also placing the project. I would argue that actually the position, the north part facing south, is actually quite good for photovoltaics. Yeah, and actually the fragmented geometry, I'm not sure if you're asking about, let's say,
a lot of surface area exposed to the cold climate.
True, but I think at the same time, actually something that Kiwi was talking about previously somehow assorted that it's not such a big issue. But yeah, the fragmentation is on one side, a lot of surfaces, but those surfaces also provide for extra surface for PV, for photovoltaics.
Okay.
Not all of them, though. That was the question. So
okay, I see.
So I'm being told that we're running out of time, but maybe Christina, I know you complained earlier that there's too many people blabbing and you're not getting your comments, and maybe you'd like to comment on this one. Are you there, Christina? In the shadow. There you are. Okay.
Did I complain?
No. In a nice way. In a nice way. In a nice way. You said you're not strong at one point and couldn't get your comment, and I thought perhaps you'd like to comment on this one.
Well, maybe somehow it has similar things that could be improved. I'm always thinking about the future possibilities of the projects. That's maybe this is wrong, but I'm always thinking about what could be done. And in terms of the programmatic understanding, maybe it's a bit too based on super prefabricated understanding of typologies. to say like, so a further understanding of possible ways of producing a space in terms of what is a new typology related with this kind of space would have been interesting. But in a future potential development of this project, because I always like them, you know.
I think there is, if I can briefly, right? I think there is a conversation maybe about the some tone that is common to the projects. That is the role of the form and the abundance of form, you know, in many different ways. That I think is good to comment in here. I think in relationship with your very initial move, which was taking and upsizing the joint. How much of these convoluted, fascinating forms are having a role in here would be nice to ask yourself about it, because I think it's super nice. I think that I found resonances with many things that reminds me, you know, the Kiwi's country, in the sense of many, well, not many, but some architects and some formal moves that they were like exploring in the 70s and 80s. But I think this role of form, how much of that is needed in relation also with, you know, the CLT planar elements becoming volumetric, and, you know, I think that would be nice, you know. And also I was just, don't take it as a criticism, I was curious about this section. Basically there is abundance of platforms and tiny spaces, but the moment when the I would say the main hall for production was shown, I was like a bit of expecting a bit more explanation about how these platforms and linear elements become enclosures and they define a space. I didn't find the section, and I was curious about the relationship with the ground. You know, how this is touching the ground, and what is the kind of relationship that it could be establishing. But I think it has a kind of a strange scale to it, which I found interesting and fascinating.
Yeah, there was a cross section on the page.
Yeah, no, I know, but it was difficult for me to understand it, yeah, to follow up and to get to know what is the interior spaces and how, you know, the abundance of platforms, yeah, becomes enclosure, and how that is done basically, and the relation with the ground. You know, I wasn't following exactly where the main ground and main hall is. But again, it's about, you know, maybe clarifying the section to push forward the aspect of how these platforms kind of structures and these linearities can start enclosing the space without losing, you know, the presence of the landscape, which I think is the most powerful point of the project, and almost the geological sense that it has.
Okay. This is the first one that makes me very sad about COVID and working remotely, because I think, Jan, it would be incredible to see like a 3 meter by 3 meter model fabricated with tools at the school of your project. But I think despite the fact that you didn't have access to that, there's a sense of construction and craftsmanship in your project that I really appreciate. And it's really a shame you didn't get to do a giant model. So maybe with Christina thinking about the future, you can do one soon.
I still have a minute?
Yes, absolutely, Mario. Always time for you.
Thanks. I'm all, since you mentioned digital craft, I'm all in favor of digital and craft. So digital craft together somehow even better. And I've been saying to my students for the last 10 years that digital craft is the future. And they only just realized that for the last 2 months, digital craft or digital end craft has been our present. Think of what has happened for the last 2 months. Craft kept functioning. The internet kept functioning. All that froze and collapsed was the global industrial infrastructure. Factories and transportation. Factories and airport disappeared. If we are still alive, we owe it to the artisan at the corner of the street who kept working, and to the internet who kept functioning. And robotic factories, when they exist, and robotic workshops could function because the coronavirus is not an internet virus, it's a mechanical virus, traveled by plane and train, etc., etc. So paradoxically, what we already know is that digital craft is not our future, it is our present. Kept us alive for the last 3 months. This said, so congratulations for being, you thought you were in the future. In fact, you have been in the present, but nobody could have anticipated that 3 months ago. The next step in your technical logic is to use intelligent robotic assembly, not to pick and choose and then smash and reduce to pulp and engineer timber to make engineered timber. The next step, when there is more intelligence in the robotic tools, is to choose a tree, to fell it, and then use it as found. So you could paradoxically avoid or circumnavigate the industrial component of your process, which implies standardizing timber to convert natural materials into industrial standard products, engineered good. I know practically still indispensable, but projecting the technology we already have only a little bit ahead in the future, it is already conceivable to take a tree as it is and to use it with minimal modification after it has been felled, which is, by the way, what artisans always did, and they still do, because you take a stem of a tree and you convert it onto a roof of a chalet. This is, you know what. So the next imminent step of your process is to eliminate the industrial mediation even more.
Mm-hmm. Wonderful. Thank you, Mario. Yes, so on that we're going to end because it's past 5 o'clock there, I believe, and we will take a break now. Is that correct, Sabina? 10 minutes, 15 minutes?
Yes, that would be perfect. So we then continue 15 minutes past 5. Is this okay?
10-minute break.
Yes.
10-minute break. Is this enough for you?
Yes. Thank you, everybody, for a great morning or whatever that was. And now we look forward to the next, I guess it's Greg's group next, right?
Yep.
Yes.
Yep. We've
Two
got
more
two.
from Greg, and then we are finished for today.
Collectively to my group there, I can see them all
All right, so we have Chen and Anastasia, and I would just say to introduce they're two very different focuses, but I think what you're going to see in both is that we're rethinking a little bit what the role of the diploma is. So we want things to be as comprehensive as possible, but we also want to have the students develop a very particular expertise and development of an approach. So with Chen, we're going to see a focus on the role of machine intelligence and programming. And with Anastasia, we're going to see a focus on scanning and artifacts and how those are experienced, the artifact versus the facsimile and the frame. But so I think it should be good. They're very different, but they're very similar in their focus. So I'll turn it over to you, Chen, if you're ready.
Can everybody see it? So, hello everyone, thanks for having me. My name is Shenhua Huang. I will present my diploma project, Reform Standard. Reform Standard is a machine learning driven searching process that designs new structures generated from existing waste materials. By using reinforcement learning, machine vision, and automated searching process, the project aims to promote a material-informed design circle and convert waste into potential resource. In the following long video, we'll demonstrate the inspiration, process, and solution of the project by constructing a shell from plastic. Reform standards questions the problematic standardization that is widely practiced in all industries. Standardization enhances efficiency and organization, but it generates increasing waste and wastelands due to its homogeneous inputs and process. The one-way process from standard has to be changed to a destandardization control process and to an alternative level of flexibility in standardization. Design has to take the material as input, to take all waste into potential resource, to take all geometries as initial design inputs. The program takes inputs of scan geometry, boundary, and design priority definition into the engine for reinforcement learning searching and generates a shell with construction guidance of each fragment and construction sequences. The program helps to digitize the waste and sort the waste into an inventory, then it generates boundaries according to the inventory and user constraints. Those inputs helps the Gen AI to play millions of times to assemble a shell and produce a construction strategy. The following demo apply with reciprocal plastic fragments to prove the concept with reinforcement learning agents. The program starts from using photogrammetry and depth camera to digitize plastic fragments. After the scanning process, all digital models are analyzed and sorted for future process and sequence of placement. After the analysis, a 2D boundary will firstly be defined according to the total surface areas of the fragments. A 3D boundary can also be generated to facilitate the learning process and construction areas that are defined by architects. In the learning part, a game environment is developed with machine learning algorithms In the past, reinforcement learning is mostly applied in game engine to train an AI to solve a task. We no longer need to search and compile methodology. Rather, we can now state the goals we want and use reinforcement learning to search for methodologies. What we need then is a game engine that the player can control and AI can take over. So a game system is developed to assemble the fragments in a defined sequence. In the game environment, a player can firstly control the fragment by moving in 3 axes, rotating, and finally placing if it can be properly assembled. Then the reinforcement learning AI can take over and try to play like a human player, and can speed up and play in multiple sets and numbers to achieve the most rewards. With curriculum learning, the agent learns to build a shell step by step, with the vision from the fragment itself to find the assembly point, then to build higher with side camera, and with the top camera to make AI build larger spans. Finally, it achieves the shell-like structure with Karamba structural analysis in real time. The AI will easily win over human players to achieve certain goals and get higher rewards. And with priority setting, the engine can apply multiple ways of observation and vision in real time. The observation of AI allows more machine vision to understand the context and react. Here it receives different lighting conditions to get a variety of shade. Height detection to get the desired height. Camera to capture support and cover areas. Karamba analysis to check the stability as a way to find new patterns of structures and optimize. Wind flows to generate different haptic experience. Symmetry observation to define regularity. Different priority settings will generate different best rewarded shells. Finally, users can choose the best shell from a selection of top-ranked results. During the process, users can always add additional fragments, and the program will step back to the sorting algorithm and resequence the inventory and reassemble the shell with new dataset. After the decision, the program generates guidance of assembly and treatment of each fragment. So the project not only revitalized waste material like circle by reusing them, but also developed a sustainable way of design that fundamentally changed the way we perceive and evaluate. The workflow was experiment with different materials and they respond differently because of the calibration of joint, tolerance, and assembly logic. Here in the project, I focus on structural parameters and Suits tries to construct a shell always. And those parameters are embedded within the logic of the code in the tool. Therefore, that is why as an architect, it becomes our responsibility and my interest to intervene and edit in the tool consciously as an architect according to our design idea and intentions. The demo shown today demonstrates the capacity of a desktop computer power to scan any geometries complicated like a ceramic or plastic pieces, and to analyze and assemble up to 400 pieces of different geometries. With the future support of cloud server to hold real-time cross-platform simulation and embedded machine learning in the coming year, the same system I developed can build larger building components, facade, or more complex building system other than solo structure or conventional building. With those new processes and new power of computation, the notion of waste would then be redefined as a new natural resource to be explored, designed, and occupied by inhabitants with ecological concerns. Now, if you would like to navigate the 3D rescanned model of the built plastic shell shown in the video, you can click the link to the website, which I will pass in the chat, or scan the QR code. Thank you for listening.
All right, thanks, Jen.
Is that done? Or are you waiting for something?
Yes,
it takes a while loading the link, the 3D model.
Yeah, I'm trying to get that link.
Greg.
So I have to say I'm very impressed, Jen.
I have to restart my machine. I've crashed.
Okay.
Yeah.
What about the structural parameters of potato chips?
That's my favorite out of potato chips.
Yeah, in that case, I have to kind of scale them up and like using similar material when they scale up. Like I think when I use this to test, I scale them up 10 times and using timber material as a parameter for the Karamba analysis.
Mm-hmm.
So you scanned each potato chip?
Mm-hmm.
Yeah.
I think it's really amazing that you've done this.
Without breaking them? Did you inject some kind of, concrete before you could break, right? This can break.
Jen, do you want to go back and play the video that shows the turntable and the camera and the process?
Yeah. So for potato chips, well, I collect different brands and find the most stiff one that cannot be easily break. Yeah, and just have to build them very carefully.
There is a brand which is.
But I think it goes without saying that one of the challenges was to decide which elements to use with the idea of scaling this exercise up to larger scale building components, because Chen was limited to, the kitchen table in his apartment in terms of the size of elements he could scan.
But in a sense, that is a coincidence, but this is the logical continuation of a presentation we have just seen, the finish, the finished installation and technical logic of that project. It was local, you grow the tree, you fell the tree, but there was the industrial processing in between. This is a demonstration of the fact that industrial mediation we can do without, because this is a proof of concept, or in fact, a demonstration of the fact that we can deal with any random, non-standard component as found, which if you project it back to the other case, it means you could deal with a tree as it grows. You don't need to process and to make it standard, because you're dealing with non-standard random components, all different. So this is, in a sense, a way to obliterate the last 150 years of technical history, because all our effort was in converting natural material into standardized materials, or to produce artificial standard materials, which had to be standard, not only for achieving mass production and economy of scale, but also because the only way to calculate them is that they have to be standard. So you can design and calculate, etc. This is an evidence of the fact that we can, in a sense, revert to an upgrade of the traditional artisanal way of making stuff by just dealing with random stuff, non-standard because it's natural, as found. Now, if you do it with potato chips, just a proof of concept. But think if you're building, a chalet on a mountain, and you want to build it with local stones, that's with boulders, big chunks of stone. You would do exactly the same thing. You send a robot around to see them, scan them, model them, then assemble them, optimizing the geometrical assembly. Exactly what you did. Exactly, you could do it with boulders. Now, this is what artisans have been doing for centuries without any tools, just by intuition. Now we can actually optimize that process using technology. This is what I think this proof of concept demonstrates.
Yeah, I agree. It's really fascinating to think about it in those terms that you, Mario, mentioned. I mean, this would also potentially take away some of the legal issues, that if you can prove that these things are structurally sound. Because one of the issues with standardization has to do with approving materials for constructions is legally safe.
It's a standard, so it's tested.
So in that sense, I think the potato chips can take us quite far. But did you think of the joints, just while nobody can have a question? Like, obviously, depending on if there are boulders that are stacked or potato chips that are assembled, I mean, they're depending on the material, there's always, of course, the issue of the joint. What is it that holds the assemblage together? If they are surface-based or massive elements or surfaces, or joint get automated and.
So for the ceramic and for the plastic, it's all like pin joint, and for each connection of the two fragments, it's always two pin joints to pair them. In the early test with the potato chips, to work with computation power, it's basically just finding the vertices, which means it can be glued, attaching the edges or pin joint. And for later on, because of the limitation of the computation power, I have to do pin joint as easy in the computation. So that's essentially the decision to limit it to one type of joint.
I think this was precisely my comment, what my comment was about. How to pass, following Greg's comment, from the model, this tiny scale, to big components, and what is the intelligence of the system in order to get to know what is the joint like, and what are the transmission of forces between the different pieces. How is that happening? Because I think that is crucial. Masonry structures are fundamentally based on the joints and the frictions and the forces that are like self-stabilizing the joints. And I think that would be a fantastic thing to think about, to scale up this process. And I was curious, I have a comment about the video, because I think, thank you for it. I mean, it was like a really, really somehow clear what you wanted to do. But in fact, it obscured a little bit the process itself that I was curious about. What kind of size, what are the limits of the size, what are the kind of joints, what are the kind of the internal logic that you embed within the system. I think that could be fundamental for our understanding. I would say the format of the demo somehow skewed that, which I think is the intelligence and the logics of the systems at the same time.
I would like to add a totally different point of view, because I think that it's extremely interesting and important and relevant to think about the role of what the diploma is. And I think that is the strength of your project, precisely, because it's not just an exercise where you are more or less skillful doing a project. It's much more a thesis, it's much more a strong diploma ending of your career. And I think that is one of the strengths. Maybe a bit of a spatial understanding in terms of the properties that you can get, the properties that these possibilities can give you, could have been done, but still is already an interesting and a strong piece of work.
I think Christina's point about what are the process of analyzing afterwards the results, they're not only computational, or they're not only based on just simply what is the performance in terms of the structure, the performance in terms of wind relation, and so on. Could have been great to understand what are the potentials of this thing. You know? Because I think what is the process that could be leading your machine learning thing to an actual construction, that could be a fundamental step to be taken. And reflecting upon what is this kind of mixed kind of tools and analytical approaches to understand the potentials of your system.
I have to say just one comment about the results. I think there's something absolutely fascinating in purely artistic terms about taking waste, like haphazard fragments of waste, into quite free-form arrangements. And then so all the messages when you look at the studies that you've done have to do with, you know, that everything you read about the parts, the fact that they're waste, that they're fragments, that they're casually arranged, everything sends a message that this is somehow accidental and not industrial and serious. And then the fact that there's actually a computer algorithm underlying the whole assemblage creates this, you know, higher level order. So there's this fantastic effect of somehow something really sophisticated mathematically going on with materials that are completely accidental and almost worthless. And that kind of dichotomy or oscillation between these two extremes that you don't usually associate with one another is really fascinating. So, I mean, just on a purely artistic sculptural level, the artifacts that you produce are really interesting.
I would also add that it's not only is Chen responsible for the programming and the building of the tool, but also it's training and it's training. So in this case, it's not a set of objective criteria applied, although there are some constraints, but it's also Chen is figuring out how to assemble. The machine is watching it. He's then reinforcing the learning and then trains it. So different people would have different, a different hand or different, you know, method of assembly to this. So, I mean, that's just part of it too. It's not purely, you know, a set of constraints and an algorithm that finds a solution. It's him training it. I mean, do you want to talk a little about that, Chen?
Yeah, so basically every little observation I set up in the camera and all the decision I made in terms of how it's observing, how it's getting reward will essentially affect how it's getting trained. So it's like trying to train the machine to start to little step by step to understand what is the show. Sometimes by tricks, sometimes by like telling how high it is. And with different setting or with different kinds of parameters, just some different change of the decimal, it will change dramatically of how it will learn. So essentially, as architect decision or user, like at the backstage to decide how this will learn or the path of the learning. And essentially that's my own parameter to tell whether they are learning in the good way or they are learning in different way.
In this case, it's ways, but you could take any material. You could take what we had discussed in the last project. You could take a trunk or a tree with branches, and you could take what you find and analyze it, scan it, analyze it, and then create any structure out of it.
Exactly.
So it's a research work on a very high level, I would say.
Mm-hmm.
So can I ask, my turn. So now it's my turn to be the curmudgeon here, I guess, and be the old guy in the room. I would love to know how this is not the same, or how this is not material sciences, engineering, structural systems, and how this is an architectural thesis. I heard a number of you say that this is a great way now to do thesis. Great. Could I get a little explanation on that, please? Why all of a sudden we don't have to draw sections, we don't have to understand it as a building, we don't have to understand it as a program, we don't have to have any of those I mean, Brian, what do you think? Does it work? I mean, has the thesis changed that dramatically? Is that okay with everyone? I'm just interested in that, because this is definitely a very, very inspired and interesting project when it comes to you know, information technologies as they enter our discipline. But are we now in a place where that we can just concentrate on that one aspect alone, and the idea of the thesis being an all kind of a full spectrum of work by students to launch their careers into this discipline has now changed that dramatically?
May I give a comment to that? I think it's an important work because it deals with a very urgent problem society has at the moment. How to reduce energy consumption and material consumption. And it could be a very important step to go to a circular economy also in building, in construction. And I would encourage Genua to continue his research also to the question of the joining technology of the parts, because this will also be a key question to keep these parts that you find somewhere and that you use, to keep them reusable. Because it makes a huge difference whether you glue them or you assemble them in a way that they can be easily disassembled again. So in order to keep that circular economy, this is the next important step.
Well, honey, I think it's...
That's bullshit, I'm sorry. That's not... You know, come on. I mean, we were trained in a situation, I guess maybe the training has changed, but we were trained where this kind of work, very, very important work, is done as a component of our work as architects. It's a very important aspect, but to totally concentrate within it, to throw everything else out, to not describe a single aspect of this thing as architecture. There isn't a single discussion here about architecture. Right? It's an engineering approach to material science and material science approach. It's great stuff. But if this is what the thesis is, then I'm perplexed, and I just like to understand a little bit more.
Well, honey, it's important to acknowledge when you might be the old curmudgeon. I know I do it all the time.
I just did. I preambled if I say that. I don't know. Look, I consider myself an architect. I'm not a material scientist. I'm not an engineer. I'm not an environmental scientist. I'm not a material expert. I am an architect. And the question,
but neither is Chen.
Can we have a discussion about architecture? Look, why can't Chen, I'm sure he wants to, but why can't he stake any kind of territory around anything to do with architectural work? Siting, program, anything. I don't care what it is.
No, but this is the language and the compositional approach that he's always been interested in.
No, he's not.
No, it is. It's consistent through his whole career at the school.
You know, we are systematically, look, I'm going to say this. I know it's being recorded. We are systematically degrading our profession to the point where we have no expertise left whatsoever, right? Experts step in. We have consultants. We have all kinds of people around us when we do buildings. The client sits there and looks at us like, so what do you bring to the table? What do you do as an architect? And traditionally, we would bring things like this into the mix, right? It's part of a larger composition. So I'm all for it, and it's fantastically advanced. However, is this a component of our discipline, or is it the discipline? If you say it's the discipline, okay, fine, I'll rest my case. This is where we're going. Good.
I think it is. I think in the same way that 30 years...
Please log off, because I don't know why Brian's sitting here. Honestly, I don't know why. Have to be.
But Hani, 30 years ago...
I'm really interested, I'm sorry. What?
30 years ago, when people like you started looking at mapping textures on surfaces, there were a lot of questions about why is this technology going to change architecture? And we had to wait, but it was proved out. I think teaching a machine to learn compositional approaches and to handle massive amounts of complexity to give you a result like this is what Chen is interested in as an architect and a designer. Like, he's only looking at this as a design tool. I don't think he's going into business as a recycler. I think he's going into business as a designer, and this is just the tool he's using.
I'm all for the tool. I think it's fantastic. The research is great. That's not my point. I just wish I wish he could speak to it as an architect, not as a kind of, a zealot of a new technology. Because look, honestly, Greg, you want to go back in time? That's the problem, right? Had you or I, back in those days, just presented our work, if I had only presented texture maps as a viable way to do architecture, and it's all about the texture map, I wouldn't be talking to you today. I'd be a technician working in some at ILM doing textures.
No, it is true. Chen's presentation was very much not the movie, it was the making of the movie. Like, I did this, then I did this, then I did this. It is very much about process, and I agree about that. And that is something, Chen, you should think about in the future, that it's better to make a larger picture argument about how this is important rather than just walking us through how you did it. It is very impressive how you did it, so I understand why you presented that way, but it does lead to confusion about whether this is just a tool or whether it's a design.
I think, yeah, it's essentially my design, and I think maybe it's the video didn't cover a part of how I try to design the composition language they are trying to build up. And I think it's more important to state that the focus is really on the architectural part coming out of the process to deal with infinite geometry, to deal with over complex geometry that in the conventional tool you won't be able to deal with, or it's too difficult to deal with. And I think that's the essential goal.
Okay, so I think we want to try to keep on schedules and move Stasia, unless Brian or Matthias, you have anything, or should we move on?
Yeah, I mean, I understand both points of view. I think it's really interesting potential, but the space as it would have been for me more interesting as well if you talked more about the actual space and how that deals with the energy issues. In a way, the concentration on the process, but not the design process, but more like a design tool or manufacturing process. But I understand. I think it's was a great presentation. But I also understand what Hani is saying very much. And for me personally, it's also my view on energy is for architects. The power of architecture is the form, creating forms which are inherently energy performance or energy efficient. So, yeah, that's my take.
But just a query, since I'm a newcomer, do you have stipulation whereby the final diploma should include something similar to a physical building? Do you have a regulation mandating to include?
It used to be the case. I think it's going out the window, but yes, that used to. When I first started, at least, that's the diploma had to be a full spectrum. That's why we have a structural engineer on the jury. That's why we have environmental on the jury, material people on the jury, construction people on the jury. But yeah, originally. Welcome, Mario.
We had no regulation, but we had a tradition. The tradition is that we always make so fully architectural diplomas. But maybe in the future we should think about it.
Yeah, because if that is the tradition and that is the expectation, then this presentation is missing the second part. We have been shown a remarkable technical leap forward in how to make a wall. Then you would expect that it is shown how this wall converts into a building. That it didn't show. If that was the expectation, it was not fulfilled. But I didn't know, but that was the general expectation.
But so I think regulation is always a term that gives me the chills around the Angewandte, because we don't want to bureaucratize. One of the most beautiful things about the university is the freedom of individual studios to determine their own curriculum and the ability to then all come together and vote and grade together. But it gives the school an experimental, innovative tool that a lot of other schools don't have with a fixed curriculum. So I would just move on, ask the question of what are job educators, and I think it's to believe the university with some relevance to the field. I think in the most banal way, we want them to be employable and contribute to offices. And often people say that the Angewandte doesn't train good terms.
Greg, you're breaking up. Is that you or is that all of us?
No, you're breaking up here as well. I think we lost Greg.
Greg is frozen.
Yeah, he's frozen.
We weren't meant to lose Greg. We were meant to just question Greg.
It makes me, just as a footnote, listening to the conversation, I was thinking of all of the experiments in parametric component-based designs that they resulted in hundreds and hundreds of pavilions and roof structures open roof structures and rarely into any architecture. But it seems like that's where if you look at a lot of the experiments in fabrication, etc., you always get a little canopy structure. And then it hasn't been very clear to see where it could go from there, except for maybe large span glass structures or something like that. But in this one, it could have been actually easy to take what Mario suggested and what Klaus pointed out and look at more architectural scale found elements and speculated on the larger scale architectural implications. Even if you didn't really do it, you could have, I think, speculated on that and thus, pointed to the potential of the tool.
So sorry I broke up. I was just saying that I think that it's important that we keep the freedom of curriculum at the Angewandte, which makes the Angewandte unique to other places. Otherwise, we become like every other school. So regulations about diploma make me nervous. I would say that as educators, it's our job to make sure the graduates are relevant to the field and relevant to architecture as an industry. And the Angewandte sometimes gets criticized by the academy and the TU as not producing graduates that can go into an office and immediately be productive. I would testify on behalf of Chen that he is imminently employable and will have a opportunity for a successful career with a diploma like this because he'll be relevant in the future. And I think that's our job. So rather than getting into whether he needs 3 sections and 4 plans, I think the real question is this relevant to the field and will it push the field? And I think it's a debate, but it's very hopeful in my opinion that
you want to have that debate now? Do you want to have that debate now or later?
Well, I think that's what diploma reviews are for.
Yeah, that's fine. No, I agree. But I think what Kiwi said is very interesting, and that, you know, the danger. I think my frustration is not so much with the work. I think it's brilliant, and I think moving the needle along like this is fantastic. And I do agree with you, Greg, that at the Angewandte there should be a kind of there needs to continue to be pushing the envelope. However, my fear, it's a fear perhaps more than anything else, is that this is relegated to a small corner of our discipline where you end up, you know, sort of basically producing something for, and you know, there's a discussion you and I had a couple of decades ago in the hallways of Columbia University that I've never forgotten. You were at the midst after Embryo House and doing all the stuff you were doing. We were walking on the digital studios we were doing. You walked through the halls. There was a show on SOM on the walls. And you said, we do all this research for those guys. It ends up in corporate structures, corporate architecture. And it's something that's always rung in my ears. I've always thought of it as a very profound moment in our own dialogue. And my question is here, what are the antibodies in place for someone like Chen, a brilliant student interested in technology, interested in the future? What are the antibodies in place to make sure that he doesn't just become a technician in the corner of SOM or KPF or another big firm? That's the question. So it's not against the work and it's not against the idea of pushing the envelope. It's about the antibodies that we put into play as architects. And part of that, I believe, whether it's old or new, that it's about the full spectrum of understanding our discipline on every level. And putting something of that into the mix, because without that, he's another potential victim for corporate architecture and basically stylized architecture. So next thing you know, you have automated cladding materials and systems going over stupid looking office buildings that are not energy efficient, that are, you know, anyway, I won't go on. Let's go on. Thank you so much. Sorry for my diatribe.
No, it's what we need. It's the debate we need to be always having. So thanks, Hani.
Then I would like to say something, because I cannot agree more with Hani. I cannot agree more in terms of, okay, we need to keep this our discipline within and as part of the work, but it's also the other part what is important. So I think that the challenge is to get both things, to really get both things.
Yeah, absolutely. And that's the richness of the Angewandte. That has always been the richness of the Angewandte. It's why it's a unique school. There are countless schools around, you know, working in these small niche moments. The fact is that, and that's why I think the thesis, and my students too, my students need to take something from what they just saw and fold it into what they're doing in their thesis work. But the point is, it is that heterogeneous mix and the continual belief in this discipline as being relevant, as opposed to just becoming technical experts.
Absolutely, but there is something about coming back to Chen's project that maybe the discussion is about that this is in a very early stage, I would say, you know, of the potential of these two. And that's, I mean, it's not a criticism, it's just that it's starting, you know, and what are the things to be analyzed for him to understand how to push forward these possibilities of this system. I think that is the important thing for himself, you know, that understanding that precisely, to bring that into an architectural relevant level. That's the point. It's not if it's a tool or not, it's a project, a conventional project or so on. It's how to elevate that work into something relevant.
But then the students have to take risks, and they have to take risks in our discipline.
Absolutely.
And put themselves out there. Had Chen just tried to cite this thing or produce some kind of a weird program or some kind of an outcome, it may have been a complete failure, but we can discuss that. That's all. I think avoiding the risks is the danger, quite frankly.
No, I would say that also we should put on the table that a diploma at the Angewandte, a requirement is it's a tour de force. If it's not a tour de force, we're disappointed. I think Chen gambled and took risks and said, if you want a tour de force, I'm going to show you a tour de force. I'm going to build an entire program that I'm going to write. and I'm going to take it as far as I can in the 12 weeks I've got. So I do think it's a requirement that we don't just do comprehensive buildings, but everything we do has to be a tour de force.
Absolutely. No one's going to definitely agree. Okay. We should move on though now because we're going to.
All right. All I can say is some people are going to be really happy with Anastasia. You're set up perfectly for your presentation. So we should take the opportunity and move.
The Alexandria Museum replicating Egypt. A big part of historical art exhibitions in the West consists of art that does not originate there. Much of this art has been acquired under dubious circumstances and does not rightfully belong to the museum that benefits from its display. In the Western Museum, this art, which has been collected, stolen, looted, etc., is displayed within the pre-existing architecture, thus muting and neutralizing the artwork's original political, historical, and cultural context in order to fit a European architecture layout and Eurocentric worldview. This act of neutralization and decontextualization of art is a potent tool of the Western Museum to appropriate art and to not have to adapt to the artifact contextually nor spatially. The neutralized artifact in return loses its ability to affect the architecture and therefore also the visitor's physical experience of the exhibition. As a result, the multiple levels of context of the artifacts get erased, the museum layout stays rigid and the circulatory progression linear, regardless of the art within. The visitor's experience of the museum remains unchanged and their outlook on art dominated by the Western-centric reading of historical narrative. But art should not be neutralized nor made to fit, especially not if it bears great cultural significance. So instead of looking at museum design which imposes an architecture on the artifact, in my thesis project I'm focusing on the design of a museum which stems directly from the exhibited artifacts. More specifically, I'm focusing on the museum design for repatriated Egyptian artifacts, currently exhibited in the West, but which should be brought back to their country of origin and be displayed in Alexandria, either as originals or as reproductions using 3D scanning technologies. To deneutralize the museum experience, physically and visually engage the visitor with the artifact, as well as to recontextualize the artifacts in their country of origin, I developed a set of scenographic principles of approaches, use and framing, movement, and layering. Scenography is a powerful spatial tool to convey information, and by using these principles, a spatial narrative can be constructed surrounding the artifacts. The museum is located on the coastline of the city of Alexandria, right next to the famous Bibliotheca Alexandrina. Alexandria has been the capital of Ptolemaic, Roman, and Byzantine Egypt, and therefore has always been and still is an important cultural hub for the country of Egypt. The museum orients itself towards major avenues of the city and thus establishes clear visual connections. The museum is housing 23 repatriated Egyptian artifacts. I assume that 20 out of the 23 artifacts will return to Egypt as original pieces. However, 3 artifacts will not be repatriated and will have to be replicated using 3D scanning technologies. The museum consists of 4 main programmatic components. It starts to form itself surrounding the artifacts through a scenographic path. This path takes the visitor on a narrated historic route and highlights particular aspects of each artifact. The route starts even before entering the museum, as one descends to its entrance from the Bibliotheca Alexandrina. From there, the visitor makes their way to the very top of the museum and back down again in a continuous loop. The scenographic path can be shortcut by the loose circulation, which runs inside the vertical core of the museum and intersects with it in the atrium space. The loose circulation offers the possibility of exploring the museum loosely with a self-constructed narrative. The core is also occupied by the visible storage. As the visitor moves from the atrium to the exhibition space, they get a quick glimpse of the stored collection. Finally, we have the exhibition spaces. While the exhibition spaces for the original repatriated artifacts are framing the exhibition pieces towards the exterior, parts of the 3 artifacts that have not been repatriated are replicated using 3D scanning technologies and reused as folias to be integrated into the architecture of the museum. The set of guiding design tools that derive from scenographic principles of approach, framing and views, movement and layering are used to design the exhibition spaces and circulation in accordance to the exhibition pieces and the surroundings. Based on the qualities of each individual artifact, the guiding design tools are used to create a unique approach to the exhibition piece. The approach to an artifact can happen frontally by descending or ascending to it, or by passing it by. Therefore, the circulation of the museum directly responds and adapts to the content within. This allows the visitor to physically engage with the museum collection. The spatial framing tools of corners, corridors, courtyards, and apertures again use the qualities of the exhibited artifacts to guide the design of the museum, accentuate the artifacts, and establish deep views across exhibition spaces and visitor amenity spaces from one side of the museum to another, and from the interior to the urban surroundings. This allows the visitor to engage with the museum collection visually. The movement scenarios within the museum encourage the visitor to stop in certain locations quickly or for longer periods of time. At these stops, the visitor's attention is being guided towards either the artifact against the backdrop of the city or the city itself. In this way, the visitor can experience the contextualization of the artifact in Alexandria physically. Moments in which the different visual layers of artifacts, visitors, circulation, and city overlap once more recontextualizes the artifact within Alexandria visually. The replica spaces at first don't reveal themselves as such from the interior. From there, they appear as just another exhibition space. But from the exterior, we start to see that the replica becomes a spolia element which is being integrated into the architecture. The replica space becomes a space to gather outdoors within the museum and to experience exterior elements which have been previously exhibited on the interior, on the exterior once again. The duality of an exterior Egyptian object captured as 2D information inside the Viennese museum and reapplied in 3D to the exterior of an Egyptian museum are underlined by the act of recreating the replica of the Viennese exhibition space as an exterior gathering space in Egypt. The geometry of the artifacts, which will never be repatriated, have been extracted from images taken at the Art History Museum in Vienna and online video footage using photogrammetry. The byproduct of this extraction process, such as texture maps and point cloud data, have been used in the design of the museum as tectonic elements of block, brick, and masonry. The gathered texture maps blend the replica exhibition spaces with the rest of the museum and the museum with the rest of the city. In the section, we once more start to see the different options of approaching the artifact, which is, for example, frontally, by ascending or descending to it, or by passing it by. We can also see the different ways in which they are being framed by corridors, courtyards, or apertures. And we can see the deep views that are being established from one side of the museum to another and out into the city of Alexandria, while layers of artifacts, visitors, circulation, and buildings overlap. Structurally, the museum can support its various exhibition spaces by using the vertical walls of the atrium as a double-layer structural core. The floor slabs are supported by both layers of the atrium core. In addition, the inner core can be stiffened by the atrium stairs by placing them in areas with the highest utilization. The cross-sections of the floor slabs which show the biggest displacement are optimized for thickness and supported by vertical walls of the program below. The museum architecture utilizes some of the vernacular Egyptian cooling methods, such as a deep cool courtyard, which allows cross-ventilation through the exhibition spaces, covered outdoor spaces, as well as bright colors of the envelope. Due to the coarse nature of the massing, it casts a significant amount of shadow onto itself. The heat from the roofs, which receive the most radiation, can however be used as part of an adiabatic cooling system. The adiabatic cooling system implements the characteristics of the psychrometric shard by taking hot dry air and cooling it by adding humidity. I think the future of museums looks more exciting than ever before. The trend to repatriate artifacts to their country of origin empowers nations that have suffered from the Western pursuit of power. In addition, 3D scanning technologies allow us to reconsider the status of the original and make it possible for these nations to recreate what has been taken during wars and occupations in new and reimagined forms. We as architects have the duty to amplify the new presence of the repatriated artifacts in the city, deneutralize the museum experience, open up the collection to the public eye, engage the visitor in a physical interaction with the exhibition pieces, and overall create spaces that are worthy of the cultural significance of repatriated art. Thank you very much.
May I add something for the sake of May I ask something?
Of course.
Oh, yeah. You said that you're using the 3 scans and point clouds and all these things, unique elements. Would you mind to explain a little bit that point, and also this space that is recreated, this exhibition space, the Viennese one that is recreated in there, and why, and what is the point of doing that precisely in the origin of the piece?
So the different text, the point cloud data is, I'm not using it specifically as point cloud data. It actually was more an inspiration for the formal implementation of it as the wall that you see here in this image. So these different particles that appear to have different colors. And why I utilized, one second here, why I utilized the interior or why I captured the whole interior elements along with the columns that I was replicating is because I just feel like their exhibition in the Viennese Museum is a very big part of their history. And if we can capture not only the elements themselves, but also the way that they're exhibited right now, and we can replicate it, I think we can create a new understanding of these pieces. And also, I think just in terms of how we perceive art these days is mostly through images and through the surroundings that they're in. And for example, I don't know, like the Luxor obelisk that is replicated as well. I think we mostly perceive that in the context of Paris, let's say.
One question, one thing that I missed. Is this supposed to be a collection of primarily or mostly replicas, or do you also show originals?
I am showing 20 originals and only 3 replicas.
Oh, so it's mostly originals and only accidentally replicas.
Exactly. So all the spaces that you see that are being replicated as exterior spaces, those are replica spaces. Everything else on the interior is an original.
Oh, got it. Thank you.
Maybe you can explain us a little bit about your original approach. When you started with the project, you thought about all those works of art that were more or less stolen from Egypt and brought to the European museums. And one of the approaches was to get them back either in a physical or in a virtual way. And now what you are showing is that you present some originals, you present some replicas, but those replicas are physical replicas as far as I understood. Aren't there also any virtual replicas? Would be the first question. And the second, what's the system behind? Does it tend to present everything about Egyptian sculpture, or the art looting, or what's the general concept or result of the museum?
So I think to respond to the first question, I did not focus on the virtual exhibition as I thought it was, for me personally, interesting to investigate which kind of spaces that the reproduction process would produce, just physically and not virtually. And this is what I've been focusing on. And I think for me, it was important that when these artifacts are being brought back and are being exhibited in Alexandria, that the main goal was to recontextualize them in the city so that they can no longer be perceived in these European spaces, and they're almost it's almost impossible to look at them without the backdrop of the city, without the backdrop of the other artifacts, without moving through the spaces in a historical narrative.
Can you go back to the previous image where you have the rendering of the interior?
Of course.
Yeah. Can you just quickly explain what's the use of image in the rendering? Is the idea that in addition to the views and the approaches or the organization that guides how you approach an artwork, that there's imagery embedded on the surfaces of the architecture?
Yes, this imagery is a byproduct of the replication process of the column, the Luxor obelisk in the temple. And this imagery is only replicated in the areas where the replica is being exhibited. The rest of the museum remains quite calm.
Okay, but how does but what is it exactly? The imagery, it's
the texture maps that have been produced by the program when I was scanning these objects.
Yeah, okay. I'm trying to be quite, I think it's a fascinating idea to think, I mean, design a museum for the artwork. And I'm sure I missed some of the thinking. I think some of the ideas there's so much work and thinking in this project already. But it seems, I mean, if you look at exhibition design and how what you're talking about really is like in trying to figure out how to build a narrative in a different way around the artifact, and you could break down the techniques for doing so in if you will, for example, in layers. One layer is the atmosphere within which you stage the artifact. Another layer could be these images that, you know, produce some sort of reference or fragments of the history of the artifact. Another layer is the literal view of the city that's in the background. Another layer is the organization or the dramaturgy of the building, of what's the sequence of the artifacts within the building? In which sequence are they organized? And then on top of that, you're thinking about the approach in a quite linear way, but you're thinking about the approach in terms of approaching frontally, from the side, from above, from below, and etc. And then on top of that, in reality, you would have things like didactic layers of text or digitally produced information, where somebody who would want to find out more, they would dive deeper into the project. So I think what I'm trying to articulate, that actually, if you're really sophisticated about exhibition design, it's this exercise in storytelling, but there's a fine, I believe it works really well when you build these layers into the environment and you allow people the freedom to triangulate or associate between the different messages and different layers, between the atmosphere and the text, between the artifact and its backdrop. And all of these things together can start recontextualizing perhaps the artwork. The risk is that it becomes something too literal, like that it becomes that you lose the pleasure of insight and discovery, and the images start undermining the artwork. Because of course, one of the techniques for making you see something is taking it away from its context, to deterritorialize something. And you can also, you know, follow this line of thinking, and it can really backfire where you overwhelm any ability to see the artifact for what it is, and you lose the nuance of its detail, etc. But I mean, having said that, it's an interesting, really interesting topic, and I think you've quite a sophisticated manner tried to think through it, and the idea of letting it drive an entire building is really fascinating. But to evaluate how it actually works is quite difficult from set of renderings and etc.
Well, I think there's one ambition. Anastasia, if you could go to that waterfront view for a minute. I think at the most, the one in the animation where you see it as a landmark. I mean, I think the desire here was, because these artifacts were originally pieces of buildings outdoors primarily, that the approach was a kind of, not kit bashing, but assembly of a building, of these building fragments. But instead of putting them inside a classicized European building and then building a kind of fake context for them in the interior, that Anastasia wanted to compose these things so you get a new kind of museum, which takes advantage of the Alexandria context. So when you're in it, you see these pieces looking out in a way that contextualizes them in the city, but also that it makes a new kind of landmark where you see it in some way as this slightly unstable composition of building fragments. Some of them real, some of them texture mapped and reconstructed. And so, but I think it's an idea of a new kind of a museum, a new kind of assembly of fragments.
Yeah.
Am I right?
That's well explained. That I never, in a review, critics shouldn't like state their own, design preferences or intent. So this is not a critique, but the way Greg described it, I can imagine a kind of minimalist version of this museum, which is purely about staging those artifacts in the city, and that's it. Like it would be a really radical museum where it's like a weird parking lot where you just encounter always the artifact in the city. But there's a lot more going on here in a kind of exploratory manner. But that in itself would be quite something.
Am I right to see this as an attempt at imagining a post-colonial museum, meaning the purpose being of bringing back to something closer to the original site, stuff that the colonial powers have stolen and taken away, and showing it in a context which should be as different as possible from that of the colonial museum where they were originally kept. But in that case, as hinted by both Greg and Kiwi, then the most logic conclusion of this approach would be to show them in something which is not a museum, to eliminate the museum as a colonial cultural construction altogether and bring them back and show them in something as close as possible to the original site. Because the museum, as a decontextualizing cultural artifact, is a colonial invention. So if you want to go against that cultural construction, you bring them back and you show them in something which is not a museum. So paradoxically, your game was to show them in a museum, which is meant to look like something which is not a museum, right?
I think it's a fascinating approach, but to that point, the function of a museum, one is to display and exhibit, the other function is to preserve, and that means at the end of the day, no matter if it's in London, Vienna, Alexandria, it ends up being in a climate controlled box, basically, and you have to sign insurance forms that guarantee temperatures and humidities for a long time, basically forever, continuously. And that, I think, is one of the challenging aspects of such a project, because it's not basically realistic to put anything except the replicas outside. Real objects will have to be preserved and therefore will always be inside, no matter where they are. And I guess
that she did.
Well, I understood some were outside, some real were outside as well.
No. The replica exhibition is one that happens on the exterior. Okay. All the original pieces are on the interior, as you can see, for example, in this video right now.
Mm-hmm. Because that's obviously always going to be the case. Therefore, context, of course, you're in maybe a place where the objects came from or close by originally, but at the end of the day, to preserve, and not only, it means also that the amount of light you can allow in is reduced to the bare minimum. So even things like opening up and backdrops and views, in reality, it becomes very, very limited because, as I say, you have to guarantee in a year the amount of light doesn't exceed a certain level or the objects get damaged. So.
Well, to that, I would actually have to say that this might be concerning a lot of paintings. However, with these kinds of exhibition pieces, we see that they're also exhibited outside freely, like, for example, in Madrid, the Temple of the Bod. And I think in this case, it would actually be to their benefit if they were thermically sealed, but the light, I don't think, plays such a big role.
What you're dealing with, I mean, the job of a museum is not only it's to preserve and to display, but really it's real museums do research and archive and as for example the CCA and what Greg has done there and so on. That's so the job of the museum is to do all this work and also build all these narratives around the artifacts or the artworks. And from the point of view of the perceiving public, the difficulty is, or from the point of view of the architect who is trying to then convey this information, what the difficulty or the challenge is to how to tell these stories. Nobody's going to read the text on the wall, and nobody's going to look at a linear video presentation. So what you have to do is precisely something that you're struggling with here, that you've quite well succeeded in exploring. You have to try to use, a multiplicity of different techniques that layer over one another in order to build like an intuitive and inherently architectural method of communicating these narratives. And the first instance is always that you have to get people's curiosity. You have to stage these things so that somebody's interested in exploring it further and finding out something. And so in reverse, the worst thing you could do is put a lot of text and information on the wall, and people will most likely just walk by it. So I think your exploration of the approach, of the atmosphere, of the use of the image, and all these things are quite, really interesting in the storytelling terms. I mean, the catch is just that you cannot really, you have to build this potential in there so that people or the visitors will create the stories in their mind. They will triangulate between all of these different elements you put out there. And that's how the information is conveyed.
I think
sorry.
I was about to say, that is a very brief comment. I see two different branches or two different directions that are so far difficult for me to reconcile. One is the presence of the figure, what Greg described as icon or landmark, and this compositional take on these different volumes around the storage space. And the other one is the problem of the replica. I think would be a great thing for you to have a look to is the really advanced companies that are doing the amazing replicas nowadays. Because the conclusion that they're having, happily enough, they're like, one is 200 meters from here, the one that is doing the thumbs, the paintings and everything else. And the conclusion for them is that it's really about almost reproducing the same kind of material processes existing in there. And I think that is a really challenging and interesting thing to be translated into the architectural scale. What are those things that could be providing a certain environment for these pieces to be showcased and to be framed in a particular way, regarding this kind of problem of yours of vision and framing? Because I think that could be a super interesting thing. For me now, there is a point of the project where it's about texturing mapping, and imagine that I'm struggling with, because I would like these material processes to be at the architectural scale, I would say, like maybe more brutal. And one of the fascinating things, just briefly, about this company, Factunarte, is that whenever they cannot reproduce the processes, they are inventing material processes that are similar to those. And that is a fascinating thing to be explored as well at the scale of the building.
Something super short, and now I pass you the word, Hani. It's very soon.
No, take your time. Take your time. It's okay.
Anastasia, the first thing. I really like you because you are very serious when you are working. I see that for us, in the work of a student, when it's determined and serious and rigorous, is always good. And there are many interesting things in your work. That's why the conversation is like so fluid, because you have many interesting points. Maybe the one that is not the best one is when everything is coming together. It's just one thing, because it's more interesting how you are dealing with the replicas than how you are dealing with the originals. It could have been done better. I know that a semester is super short, but I can buy Greg a definition of the assemblage of species. You didn't explain it like that. I don't know if this is something that is the reason why it's not coming through in a more sophisticated way. You are super sophisticated. Many topics that you are addressing and what you are trying to do are super sophisticated. And maybe you could go for the Kiwi advice, being more radical, because it's more interesting. Certain things that you have put on the table are extremely strong. But really, congratulations, because just having this kind of conversation means that you have many interesting points.
We should end on that because it's a good closing statement, but I just need to say one thing, not to have the last word. No, but I think the desire to do a museum based on looting, raping of cultures, you could almost say, on the violation of people's, I mean, this goes the whole gamut from the Elgin marbles to things here at the Met all over the world, is a fascinating premise for a museum. A museum based on the reappropriation of culture is, I can't think of a higher bar or a higher calling than to create a museum around that theme. I think it's a brilliant theme, absolutely. I think the circulation is what's really cool about this project, quite frankly. The way that you approached the notion of framing, of views, of placing artifacts, and so on and so forth. I even think the idea of texture mapping and distorting and even potentially using machine learning to reappropriate works is kind of a very fascinating idea. But there are two criticisms on those two fronts. One is, you have to stand back, I think at some point we have to. Now this is going to get me in trouble again. I'm sure Greg is going to go after me on this. But at some moment, you have to stand back and say, is this the appropriate thing for this place? Okay, this is a part of the world that's been ravaged by wars, by all kinds of political problems. There are pictures of buildings in the Middle East that look like this, but they've been bombed, right? They've been destroyed. So there's a certain aesthetic here that, whether it's by accident or otherwise, it speaks of destruction. And I don't know how appropriate that is to this, number one. The second thing is, it would have been a very cool idea, maybe you already thought of this, to say, okay, you know what? We're going to send it back. We take the original back to Alexandria, and I'm going to show you galleries at the Louvre, at the Met, at wherever that I've designed for the virtual versions of these things back in the other context, so that if you visit the Louvre or you visit the Met, the Egyptian wing at the Met, you can still see the Temple of Dendur. But the Temple of Dendur has been reinterpreted into a gallery space that you've created, much like what you're doing here on the outside of this building, as an interpretation. That would have been a really interesting, it is an interesting extension of what you've said, right? So you do a kind of a conduit building. And I really like what Kiwi said, that perhaps the physicality of this thing is the mistake, because if this thing existed as kind of almost atmospheric, as artifactual, and as a two-way street to these other cultures around the world, to the other places around the world that in fact are guilty of everything you're talking about and don't know how to return these things. I don't want to return them, quite frankly, because they lose their market share and their audience. That's the intellectual discourse here that is super cool and super tight. I just think that you fell into some kind of tropes and attitudes to building design that need to be more disciplined, and the brutalist outcome of this thing stylistically, I don't know if that's appropriate. I don't know if that's the right thing. I wonder if, in fact, Kiwi's point, I don't know if that's what he was saying. I know he wasn't trying to design your project, neither am I, but I can't help myself. I wonder if, in fact, it isn't more about the internal viscera of this building and what it intends to do than the look of a, you know, a kind of cliche brutalist icon on the waterfront. You know, that's my 2 cents. Sorry. But it's a fascinating. I mean, I applaud your desire here to bring this question to the front, because it's a really interesting premise for a museum, and for building cultural buildings and cultural architecture in cities. It's a powerful statement.
All right. Well, I think great work, Anastasia and Chen, and great jury. I mean, great conversations on the diplomas that they sponsored. So that's all very good. I think we're halfway, so we don't really need any wrap-up statements or anything. We maybe want to like unmic everybody and give a round of applause to the 7 diplomas today. But otherwise, do we need anything? Does anybody want to say anything closing, or do we want to just, I'm kind of ready to have my breakfast. I'm sure everybody's ready to have some dinner. But we're going to meet at the same bat channel at the same bat time tomorrow. So
good.
It's a great.
All right. Well, congratulations, everybody.
Thanks for great work.
The channel for tomorrow. Sorry to interrupt. The channel for tomorrow is a different one. It's not.
You're right.
It's not the same.
Yep. Sorry.
No problem. So we see tomorrow.
See you.
Sorry, the agenda or the channel is different. I didn't understand what you said.
Same time, different channel, a
Yes.
different Zoom link.
Yes.
Are you sending out the link again?
I can resend it. It was in the email, but I will resend it right now.